So, ma'am is going to join very soon as a director, ICR in Indian Institute of Millet Research, Hyderabad. At present, she is a project coordinator, ICAR, AICRP on Pearl Millet since 2016. Regarding Madam education, she has completed her BSc Agriculture and Master's degree from Agriculture College, Bapatala, Achar NG Ranga Agriculture University, and she has obtained her PhD degree from Division of Genetics, IARI. Regarding her professional career, so she joined ICAR in 1998 at National Research Center for Soybean, and then she came to IARI as senior scientist in 2006 and served there as principal scientist as well. And during 2017, she joined project coordinator ICR AICRP on Pearl Millet. And congratulations, ma'am, to you from my side on behalf of all the organizer and all the participants for joining as a director, Indian Institute of Millet Research very soon. So regarding ma'am's achievement, so ma'am developed minimal descriptor in soybean, which is very important for dust testing in soybean. Then she has identified QTLs for seed coat permeability in soybean crop. Regarding hybrid and varieties, so she has developed 2 hybrid and 3 varieties. She has identified very unique genetic stocks for high lysine, tryptophan, iron, zinc, and white grain in millet. So she has great role in the biofortification of the millet crops. She has also identified QTLs for downy mildew resistance in the pearl millet. Her great contribution in the AICRP pearl millet is she has introduced benchmark levels of introducing iron 42 ppm and zinc 32 ppm content in the promotion criteria of the AVT for cultivar release. It was for the first time in the world. Because of that, she could able to release 32 hybrids and 2 varieties in pearl millet with increased level of iron and zinc content, and which will lead to nutritional security to the Indian population and the global population as well. Regarding publication, ma'am has published more than 140 research papers, 3 books, and she has also guided 3 PhD and 9 MSc students at IARI, New Delhi. And regarding her recognition, awards, and fellowship, she has obtained gold medalist in UG, PG, as well as at doctorate level. He has received Dr. Punjab Rao Deshmukh Outstanding Women Scientist Award from ICAR in 2016. In addition, she has received Outstanding Millet Scientist Award from Government of Karnataka during 2018. Madam has also received from Indian Society of Genetics Plant Breeding Swaminathan Women Scientist Award in 2019. In addition, she has served the Genetics and Plant Breeding Society in a great way. She has served as a vice president in Indian Society of Genetics Plant Breeding. Then she is also the fellow of Indian Society of Genetics Plant Breeding. So today, we are grateful that Madam has accepted our invitation, even in spite of her busy schedule, to deliver the talk in our training program and to the participants. So Madam, we welcome you to deliver the talk on millets as functional food and nutraceuticals. As being the International Year of Millet, this topic is a very burning topic. So, so with this, I'm stopping my slide. And Madam, please share your slide and speak to the participants.
Okay. Thank you, Dr. Jyoti, for your nice introduction. Let me share my screen. You're able to see my screen?
Ma'am, presentation mode.
Now it has come into slideshow?
No, ma'am.
No, ma'am. Just double click.
Let me undo and again do it. You're able to see?
No, ma'am.
No, ma'am.
No, ma'am.
मैम सबसे पहले पावर पॉइंट की फाइल को खोल लीजिए. यस.
खोल दिया है.
देन उसके बाद प्रेजेंटेशन मोड.
ओके.
डबल क्लिक नहीं ले रहा है क्या?
मुझे तो इधर दिख रही है, आपके उधर नहीं दिख रहे.
I think it's, ma'am, file is very heavy, so
It takes some time. You are able to see the slides or not?
No, it is not in slideshow.
But here it is in the slide.
Slide is visual, but not slide mode. Good morning, ma'am.
Yeah.
Ma'am, slide is visual, but not slide in mode.
But it is okay if it is not happening, because I think.
Let me try
Ma'am,
one more time. Let
मैम
me.
पहले अनशेयर करके दोबारा शेयर करिए मैडम. स्लाइड को खोल लीजिए पूरा. आप शेयर करिए मैम.
बार वही आ रही है.
अब हो रही है ना मैडम? हाँ, अब हो जाएगी. स्लाइड मोड पे जाइए.
अब तो हो गई है, स्लाइड मोड में है.
हाँ, मैम आप चालू करिए.
Okay then. Thank you.
Yeah.
Very good morning to all the participants, the organizers, everyone. First of all, I would like to thank the organizers for rescheduling and accommodating my request. As rightly pointed out by the organizers, Dr. Jyoti, year 2023 is the most happening year for international, being an international year of millets, and everyone is talking about millets. Though this training program is related to PGR, but the organizers are really mindful in accommodating this lecture, because when you are hearing all around about millets, it is our responsibility also to make few people aware about the good properties of millets, like how they are being called as functional foods, and why they are called as nutraceuticals. So I thought this is the right opportunity to share our knowledge and experience with you people, why millets are being called as functional foods and nutraceuticals. So the slide is visible, no? Second one?
not visible.
Second one, not visible, ma'am. Just double click करके, then you cursor down you can do, or on slide right click करके next slide. That will work, I think.
Now?
Not, madam.
What I'll do is I'll send my presentation to you. Jyoti, I'll forward it to you.
Ma'am, okay.
Okay? You
Okay,
please do from your side otherwise.
Okay, ma'am. Okay.
Sorry for this trouble.
No, it's
Moving,
fine.
ma'am. It is moving.
Okay.
Moving, ma'am. Yes.
Okay.
Yes. No. Moving about millets.
Yeah. Yes. So when we talk of millets, the first thing is what are millets? Millets are the collective group of small seeded annual grasses that are grown as grain crops, primarily on marginal lands in dry areas of temperate, subtropical and tropical regions. And these are one of the earliest grains that are being cultivated and consumed by the people in India and the world. And these are the most climate resilient crops. And these are grown in nearly 131 countries. And their cultivation dates back to more than 3000 BC. And when we talk of millets, we have two groups, major millets and minor millets. These include sorghum, pearl millet, and finger millet, and together these three occupy 95% area of the millets. And minor millets include which are foxtail millet, proso millet, kodo millet, barnyard millet, and little millet. And the total area of these contributes to only 5% area. And in India, when we talk of pearl millet, sorghum, and finger millet are important major millets here grown in this country. And pearl millet and sorghum, they rank third place. Pearl millet ranks third after rice and wheat in India. No, fourth place after rice, wheat, and maize. And finger millet is also a major part of the food basket in some states like Karnataka, Telangana, and UK. And other millets are being cultivated in varying scales in various parts of the country, mainly by the tribal and marginal farmers. So if you can see that these are the millets, the upper ones where I'm showing here: pearl millet, sorghum, finger millet, foxtail millet, kodo millet, till finger millet. These are the three major millets. These remaining are small millets. So foxtail millet called as kangni, kodo millet, then little millet called as kutki, proso millet called as china, barnyard millet as sama, then brown top millet called as choti kangni. And to this group again, we have 4 more additions, 2 called as pseudo cereals like buckwheat, that is kuttu, and cholai, that is amaranthus, and 2 exotic millets, namely teff millet and ponya millet. If you look into the cultivation at the global level, the total millet area is about 74 million hectares, and the total production is 89.17 million tons. And 90% of area and production is contributed by sorghum and pearl millet together. And of this total production, 20% is contributed by India, and India is the 5th most important exporter of these millets. And area-wise, India is the major contributor in area and production. So you can see the statistics of production of area and area and production by different countries. And if you look into the millet map of India, Rajasthan is the major state cultivating bajra and sorghum. Karnataka, you have jowar and ragi. Maharashtra, ragi and jowar. UP, bajra, and Haryana also bajra. And you can see in this map, we try to represent different millets which are being grown in different parts of the country and in different states. Now coming to area, production and yield of millets in India. Before Green Revolution, the area was something like more than 20 million hectares, more than that. But after Green Revolution, the area under millets decreased by 20 million hectares. But in spite of decrease, there is an increase in productivity. So in spite of the decrease in area, the production did not affect much because the productivity has increased. So when you see the statistics, it is very clearly shown that the millets area is reduced down by 50%, but still the production has increased by 32% and the productivity has increased by 159%. Now coming to India also, if you see state-wise, at present, the total area of millets in the country is 13.63 million hectares with a total production of 18.02 million tons and productivity of 1322 kgs per hectare. And this pearl millet occupies 44.5% of the total production, then followed by other millets. And India is the 5th largest exporter of millets, earning about $31 million with more than 50% of the exports coming from the state of Gujarat and Karnataka. The top 3 importers of millet from India are Nepal, UAE, Saudi Arabia, and the other countries apart from these 3 are Libya, Tunisia, Morocco, UK, Yemen, Oman, and Algeria. Now, if you see the trends and distribution of millets in area and production wise, in the total area of millets, Bajra, that is pearl millet, contributes about 54.5% total area, followed by 34.9% by sorghum, then ragi 7.3%, small millets 3.3%. When you look into the production, Bajra alone contributes to 60% of the total millet produced in the country. Then sorghum 27.6%, ragi 10.2%, and small millets only 2.1%. Now, why millets production is beneficial? Because they provide nutritious food, feed, and fodder. They consume less water compared to other cereals, and they have very less carbon footprint and water footprint. They grow faster, putting less stress on the environment, very less number of insects and pests and disease problems. They can grow in even poor and marginal lands. Especially in case of pearl millet, no other crop can grow, their pearl millet can grow. And these millets, they provide complete food and nutritional security. They also supplement the existing income of the farmers. How? They reduce the cost in groundwater extraction. And in desert areas like Rajasthan and other places, they combat desertification. And also they provide increasing resilience to the farmers, which are brought by droughts because of the climate change. And you all know that United Nations Food and Agriculture Organization has declared year 2023 as the International Year of Millets. And also, you must be aware that Government of India has renamed millets as nutri-cereals for production, consumption, and trade point of view through a Gazette notification issued on 13th April 2018. So all these millets which I have shown in the beginning are coming under the category of nutri-cereals. If you look into the nutritional composition of these different millets in comparison to the major staples like rice and wheat. So wheat and rice are here. And you look into the carbohydrates, protein, fat, energy, dietary fiber, calcium, phosphorus, magnesium, zinc, all these things. You could see that different millets, different strong points. Pearl millet, it has high protein. Then proso millet also have very high protein. Then iron is very good in pearl millet. Then you can see thiamine is very good in proso millet. Varying amounts. Then in millets, here in amaranth also you can find 13.3. In buckwheat also 13.3% protein. This is really a good, very good source of protein for vegetarian people. So if you look into the present day challenges we are facing today, on one hand, we have the ever increasing population, coupled with you have different levels of micronutrient deficiencies. And again, we have glaring into our face this global warming, water scarcity. Apart from these, we all have gone through and are going through this COVID-19 pandemic. So this COVID-19 pandemic has brought out where we stand from the health perspective. What are the levels of immunity we have with us, and what are the things we need to take to boost our immunity? So when we talk of health, hello? So if you look into the health benefits of nutri-cereals, they are beneficial in detoxifying the body, They lower the bad cholesterol level. They prevent the onset of breast cancers. They help to prevent type 2 diabetes. They help in reducing blood pressure. They help to protect against heart disease. They aid in treating respiratory conditions such as asthma. They help to optimize kidney, liver, and immune systems. They reduce the risk of gastrointestinal conditions like gastric ulcers and colon cancer. They eliminate problems like constipation, excess gas, bloating, and cramping. These are all the issues we generally face in our day-to-day life, except the cancers and other things. So how these millets are going to contribute and how they are good for our health. So when millets are becoming popular, people have started asking, what is the proof? Are there any scientific studies? Yes, now people are taking up experiments and trying to prove scientifically that these millets are really good. So I'm trying to bring out in my presentation the benefits of the millets, and also wherever I've found some scientific studies, I've tried to put them at those particular places. So here in this slide, you can see the impact of sorghum supplementation on growth and micronutrient status of school-going children in southern India. So here the subjects are residential children, 160 boys and 160 girls between age groups of 9 to 12 years. They have been fed with sorghum diet and 60% sorghum and 40% rice. And they compared with control group with where they have taken 100% rice diet. So after this complete feeding with this particular diet, they could see that they had higher growth rate, higher hemoglobin levels, higher serum folic acid levels, higher calcium levels, higher iron levels, and also higher levels of retinol binding proteins. And this study is published in Indian Journal of Pediatrics in 2016. Now, when we come to see what is the status of the non-communicable diseases in India, there is a constant increase, significant increase from 37.9% in 1990 to 61.8% in 2016. And you see the cardiovascular diseases increased from 2.9 to 6.6%. Chronic respiratory diseases, they shot up to 4.4%. Diabetes, now it is more than this, 2.2. And cancer also, it has shot up. This because this particular data is only talking of 2016. This is the latest data I could lay my hands on. Now, any grain, any cereal grain or any food we take, generally it contains 3 or 4 things: carbohydrates, proteins, fats, vitamins, minerals, and some other phytosterols and all those compounds. So if you look into the component wise, in the carbohydrates in different millets, you can see generally it is varying from 55 to about 70%. So different millets have different quantities of the carbohydrates. Now in these also, the free sugars that are found in millets like glucose, fructose, sucrose, and daphnose, the range varies from different percentages, and these available sugars, they play a significant role in the digestion and absorption in the body. Now, in the carbohydrates, we have again starches, sugars in available form, in non-available form. I am not going into detail of all those things, but this is one table which can give a clear idea of how much total available carbohydrates, total starch, fructose, glucose, sucrose, maltose in different millets, and in comparison with rice and wheat. Then we also quite often listen and hear that doctors say that you should take more of fiber. Fiber wala khana khai karke bolte hain. Don't go for these refined starches or refined flours. because they will not help in movement of the food in our intestines. So they say that we should take foods which are rich in fiber. And millets are rich sources of insoluble and soluble dietary fiber. And they have comparable or even higher total dietary fiber compared to other cereals. Now, if you see millets, they have good amount of dietary fiber. So what is the function of these dietary fibers? They are helpful in water absorbing and provide bulking property. And what is the health consequence? So they're energy diluents to formulate low calorie diets. Someone wants to reduce obesity, has to lose weight, then they have to shift for millets or incorporate millets in their diet. If you see sorghum and finger millet, they have increased transit time of food in the gut. So they slowly go through the gut. They pass through the gut very slowly. That means they have reduced risk of inflammatory bowel disease. Then pearl millet. Pearl millet, sorghum and finger millet, they have bile acid and steroid binding property. That means it is helpful in hypocholesterolemic activity and reduces the risk of cardiovascular diseases. Then again, sorghum, pearl millet and finger millet, they retard the carbohydrate absorption and impaired glucose tolerance. That means it will help in management of certain types of diabetes. Sorghum, it is having binding of toxins, so it can be used as a detoxifying agent. Proso millet and foxtail millet, they are again, they bind to divalent cations. So this means unprocessed. You have both good properties and negative properties of this millet. But mostly, most of them have these good properties. And here in this table, we are again trying to show the approximate dietary fiber content of millets compared with major cereals like rice, wheat, maize. So those are interested, they can go back to these tables which are available in the book Indian Food Composition Tables released by National Institute for Nutrition in 2017. Now, we quite often hear the word constipation. And I think there was a movie also related to this constipation. So what is this constipation? It refers to a disease in bowel movements or difficulty in passing the stool. The incomplete evaluation of the bowel, even when bowel movements are frequent. This implies that waste residue builds up on the colon walls and is not properly excreted with the movement of muscle. So if the stools are not passed out and the waste is not excreted out from the body, it has its own repercussions, and that will lead to diseased condition in the body. So because millets have abundant dietary fiber, just now we have seen, I'm sorry.
Ma'am, have some water, ma'am?
Yeah, I'm having.
Okay.
So millets, they provide good amount of dietary fiber, and this helps in the movement, the bowel movement freely. Also, mineral content vary in different millets. They have higher amounts of calcium, iron, potassium, magnesium. Finger millet has the richest or highest content of calcium, and other millets have good phosphorus and iron. Pearl millet is having very high amount of iron and zinc. Magnesium is a micronutrient that is essential for both mineralization, teeth maintenance, building up of proteins, enzymes, and all these things. Then sorghum is a good source of potassium and practically devoid of sodium. And pearl millet is very rich in iron and zinc. And when we talk of this millets and mineral content, you all must be aware that we talk of micronutrient deficiency, hidden hunger. Hidden hunger is that one which is because of lack of sufficient quantities of micronutrients in our body, and they lead to different problems. And the major repercussion of hidden hunger is anemia. Anemia means it is a decrease in the total amount of RBCs or hemoglobin in the blood, and then it is lowering the ability of the blood to carry oxygen. Thereby, the energy levels in those subjects will be less. And because the energy levels are less, you feel fatigue, you feel irritated, you don't have concentration, and you will not be able to focus on your work. And there are many other things which are repercussions of this anemia. And in India, many of the women, young girls, adolescents, children are subjected to anemia, and consuming pearl millet, because it has high amount of iron and zinc, can lead to alleviate this problem of anemia. And in pearl millet, we have some biofortified pearl millet hybrids. And right now, Dr. Jyoti also mentioned that we have introduced this concept of benchmarking. So any hybrid or variety which would be released to ASRP in pearl millet, in spite of its higher yield content and other desirable traits, if it does not have a minimum of 42 ppm of iron and 32 ppm of zinc, we are not going to promote it nor identify it for release. And even when those things come to varietal release committees in the CVRC, that time also those hybrids or varieties which do not have this benchmark level of iron and zinc, and they may be discarded at that point of time also. So this is the first kind of effort and activity that was taken up to ensure nutritional security in the country. Then when we talk of protein, the average protein content of millets is reported to be something like 7.7 to 11.8. This was something in 1980. Just now we have seen that the protein content is as high as more than 13%. So millets, not only they provide good amount of good fiber, good carbohydrates, good resistant starches, they also provide good amount of protein for those vegetarians and others also when they consume them. So if you look into the amino acid profiles of millets and major cereals, you can see here pearl millet, sorghum, ragi, and little here in wheat and rice. You can see how different amino acids are varying in different cereals and in different quantities. Now coming to lipids, we have lipids, and where are these lipids located? Mostly in the seeds, in the grains. They are concentrated in germ, pericarp, and allurar layers. And if you look into the fatty acid composition of millets and major cereals, you can see here again different fatty acids are given. And also these millets are good in unsaturated fatty acids, which are good for our body, good for heart. Polyunsaturated fatty acids. Like you can see stearic acid, oleic acid, linoleic acid, all these are unsaturated fatty acids. So when you also, there are now people are facing the situations like fatty liver. Those previously people used to see this condition in those people who are mostly alcoholic. The fatty liver situation used to be seen in alcoholic people, but now we have non-alcoholic fatty liver disease. So if we have to reduce this occurrence, we should increase the intake of good fats. And that good fats we find abundantly in millets. And there is a study which was published in Food and Function, the one published by Royal Society of Chemistry. They have shown I'm sorry. So consumption of different millets has reduced adipose tissue deposition, and then hepatic steatosis and systemic inflammation. So when we go into the deep medical terms, you can understand all these things, but right now I'm just trying to bring a bird's eye view of how these millets are going to help. Next, coming to vitamins. These millets are also rich in important vitamins like thiamine, riboflavin, folic acid, and niacin. And generally, they are not a rich source of vitamin C. We don't say that millets are rich in vitamin C. But when they are sprouted, that means when they're germinated, it was found that the vitamin C content increased. And these are the different vitamin profiles of different millets like thiamine, riboflavin, niacin, pantothenic acid, biotin, and different millets. And if you look closely, pearl millet has then, if you see thiamine, it is high in foxtail millet. Riboflavin is high again in common millet. The niacin is high in foxtail common millet, and different millets have different major what are those vitamins which we generally talk of. This is how we try to show here. And if you look into the folic acid content, pearl millet, finger millet, little millet, kodo millet, they have similar levels of folic acid. And then there are certain phytochemicals which are very essential for human body. They act as antioxidant, and also sometimes they serve like hormones. So phytochemicals like phenolics, lignans, beta-glucans, inulin, resistant starch phytates, sterols, tocopherols, dietary fiber, anthocyanins, carotenoids, phenolphthaleins, all these are present in different millets. Again, I'm not going very deep into this. Those who are interested, they can search. And there are certain anti-nutrients also available in millets, like phytates, polyphenols, oxalates, tannins, which when they're present in large quantities, they affect the mineral bioavailability. So we need to see which kind of millets have what kind of anti-nutrients or all these things. And then accordingly, depending on our health condition, we need to take a balanced diet, including these millets. Quite often nowadays, we are hearing this gluten sensitivity or celiac disease. It is because the gluten protein present in wheat, in some people, it causes similar allergy symptoms like mouth, nose, eyes, throat, etc., rashes on the skin, problems in respiratory tract leading to wheezing, difficulty in breathing, and then gastrointestinal tract like cramps, nausea, diarrhea, and abdominal pain. So the exact cause of the celiac disease is not very clear, but the percentage of population affected by celiac disease is very less, not even 1%. But since it is an autoimmune disease, people are trying to avoid those foods which are having gluten, which would enhance the celiac disease. So when you look into such cases, in such conditions, millets serve as a better source because they do not have any gluten. So in such conditions, since pearl millet, sorghum, ragi, and other millets do not have any gluten, they serve as a boon or a very good alternative source for those people who are suffering from celiac. And also it was observed that many of the people have this problem of arthritis. And whenever gluten foods are taken, the gluten present in those foods is acting like a trigger for the joint pains. Especially arthritis is nothing but the problem with the pains in the joints. So if we are taking foods with high gluten or gluten, indirectly without our knowledge, that is acting as a trigger for joint pain. So more of inflammation, more of pain. So try to avoid those foods which are having gluten. Then the alternative available is take millets. That's what we are saying here. Then diabetes. We all know that India is the world hub for diabetes and mostly prevalent, and the young youth and middle-aged people are many people who are suffering with diabetes. And the side effects of diabetes, it causes blurred vision, excessive thirst, frequent urination, then less absorption of blood glucose, and all these things are there. Prolonged exposure to diabetes, it may affect important vital organs like eyes, kidney, heart, nerves, and it may damage the small blood vessels. Many things are there. So how we have to reduce diabetes? We need to focus on management and reduction of the postprandial glucose condition. That means then we have to see what are those foods which will not increase the postprandial glucose level. Then the answer is millets, because they are slowly digestible and they release sugar slowly into the bloodstream. So when the quantity of sugar released in the bloodstream is less and slow, the body will be able to use that sugar in a given period of time. When there is no excess sugar available, then your sugar levels will not spike up. That means we need to focus on what kind of foods we are eating. And when we look around to see which are the foods which are having low glycemic index, that is a value which shows that this particular food has high glucose releasing capability or less glucose releasing capability. Then when we see the glycemic index, millets are very good with low glycemic index values. So people who are suffering from diabetes, they should try to increase the intake of millets. Then some studies, they try to show that by consuming millets, diabetes can be managed. So a paper in the Frontiers in Nutrition in maybe 21, which shows that a systematic review and meta-analysis of the potential of millets for managing and reducing the risk of developing diabetes mellitus. So the study showed that all millets had significantly lower GI compared to rice, refined wheat, standard glucose, and white wheat bread. And they also, based on their study, they have identified that foxtail and barnyard millets had less than 55 glycemic index. Pearl millet, finger millet, kodo millet, tetil millet, and sorghum, they had intermediate of glycemic index like 55 to 69. And long-term consumption of millets lowered fasting and postprandial blood glucose levels. And in the end, it is very clear that millets are 30% more effective in lowering glycemic index of a meal compared to milled paddy rice and refined wheat, therefore useful in management of diabetes. Then other factor like obesity. If you see the young children, adolescents, and the youth mostly are becoming obese because of the food habits. If you see the present generation, they eat more of chips, more of burgers, more of pizza, and all those cakes, pastries, all made from refined flour. And then this increases the body weight. Then the side effects of increased body weight, coronary artery diseases, strokes, insulin resistance, and all these things. So because millets have rich dietary fiber and they're good in water absorption capacity, they give the person who consumes millets some fullness and prevent them from taking more food. So this is how the intake is also regulated, and because of the high dietary fiber, the movement in the bowels and gut is also regulated. Thus, it improves the overall digestion and absorption capability of the individual. Recently, there is another paper in Frontiers in Nutrition in 2021. Here, this is a compilation of 19 studies they had published in this. Can millet consumption help manage hyperlipidemia and obesity? And the outcomes of this study, they showed that consumption of millets for periods as short as 21 days to 4 months reduced levels of total cholesterol, triglycerol, LDL, and VLDL. On consumption of millet-based diets, there was a 6% increase in HDL and 5% reduction in systolic and diastolic blood pressure and 7% reduction of body mass index. Now, cardiovascular diseases are also another important health issue we are facing now. And here, in these cardiovascular diseases, there are many issues, many tissues which are affected, especially in case of heart, the muscles, the valves, the rhythm, and all these are affected. In some cases, some may be affected. In some cases, all the things are affected. Different people have different levels of problems with cardiovascular issues. So since millets are good sources of magnesium, these magnesium is known to be capable of reducing the effects of migraine and heart attack. And also millets being rich in phytochemicals like phytic acid, it is essential and it is known to lower the cholesterol. Tannins present in millets are also known to lower the cholesterol. So different minerals and phytochemicals present in millets are able to reduce all these cardiovascular diseases. And so if you are interested in managing the cardiovascular diseases, when you go to doctor, they say that get your lipid profile. In the lipid profile, what do you see? LDL, VLDL, all these things. And prevention of LDL oxidation is very important in prevention of cardiovascular diseases and hypertension. And prevention of LDL oxidation by millets is attributed to their antioxidant property because of the presence of phytochemicals present in their seed coat. And also millets have shown that they can increase the levels of high density lipoprotein, which is a very good cholesterol, a form of cholesterol, good for cardiovascular disease management. And a paper in 2010 showing in Science Direct, that is nutrition research, millet consumption decreased serum concentration of triglyceride and C-reactive protein, but not oxidative status. So they have shown that consumption of foxtail and proso millets resulted in reduced levels of serum triglycerides. Foxtail millets have lowered the C-reactive proteins. So if you go again into the medical terms and then you understand, you can go in deep and read the literature. But for the presentation sake, I'm just trying to bring out a few papers and bring them and present to you. Then millets and hypertension, here we have 3 papers, one from Journal of Functional Foods, then Journal of Cereal Science. They also show that partial replacement of regular staple food with millets, it resulted in significant reduction in the systolic and diastolic blood pressure. And millet diets are found to lower the increase in blood pressure and oxidative damage. And millets can play a significant role in management of hypertension. Then millets also have a good role in reducing the cancers and their management. In a study published in Journal of Agriculture and Food Chemistry, they have shown that the foxtail millet bran is able to reduce the extent of tumor growth in mice. So they try to show how millets can reduce the cancer tumors also. And also there was a study on infant gut health. Those infants who are feeding with millet foods, they're found to have good in the infants. In northern states, now there is an increasing trend, especially in states of Rajasthan and Haryana. You see the instant infant food like Cerelac and other mixes are available. People are now replacing those market available infant foods with homemade millet food to the children, so that they get the flavor and taste of the millets right from their childhood and can have a good acceptance of the millets in future also. So the young mothers who are really health conscious and caring for the future of their children are shifting from the market-based foods to millet-based foods. Now, if you look into how these millets are consumed, we have diverse forms of consuming millets in different traditional food forms and different forms and snacks. Here, this is just a depiction. There are about 500 plus recipes developed by IIMR Hyderabad. And then you have different millet processing technologies like puffing, flaking, baking, extrusion, then fortification, instant mixes, and recipes available. And also we have different things like the present young generation who are attracted to cookies, bread, cakes, using millet flour in place of wheat flour or the refined flour. Then you have different flakes from different millets here: Proso millet flakes, barnyard millet flakes, pearl millet, finger millet, sorghum, little millet, foxtail millet, kodo millet. And apart from these good properties of millets and research being done by different scientific communities, the policy decisions also have a big role. So the government of India and other state governments are taking good initiatives and important initiatives to promote millets. First one here, the Pradhan Mantri formalization of micro food processing enterprises. In these, many programs were launched under the Atmanirbhar Bharat Abhiyan. It is being implemented in many states and union territories. Then production-linked incentive scheme for food processing industry to support creation of global food manufacturing champions, promote Indian brands of food products across the globe, and increasing employment opportunities for off-farm jobs and all these things. And also DAC has supported establishing 3 centers of excellence, one at IIMR Hyderabad, one at Hisar, and one in Bangalore. These centers of excellence, they have come out with many value-added project technologies. IIMR alone, they have added about 70 plus value-added technologies and SOPs. And also, Government of India is providing some agri-infrastructure fund to support the financial assistance to set up primary processing units related with millets. Apart from these, we have organic farming policy by Government of Karnataka, Odisha Millet Mission by Odisha, Chhattisgarh Millet Mission, Telangana Millet Mission, Assam Millet Mission, Haryana Millet Mission, Rajasthan Millet Mission, Millet Village Scheme by Kerala, comprehensive revival of millets cultivation by tribals in Andhra Pradesh. There are many things. Apart from this, again, now you all are witnessing this International Year of Millets 2023. And you know the genesis, nearly 72 countries have accepted this proposal by United Nations General Assembly to declare 2023 as International Year of Millets. So, Government of India is celebrating International Year of Millet, and there are 7 points, 7 sutras under this. That is, one is enhancement of production and productivity of millets. The responsibility is given to DAC, Department of Agriculture and Farmers Welfare, and DARE. The nutritional and health benefits to the government, Ministries of Health and FSSI. value addition, processing and recipe development to MOFPI and tourism, entrepreneurship, startups, collective development to commerce and again agriculture and farmers welfare, awareness creation, branding, labeling and promotion to all the ministries, international outreach by Minister of Commerce and Minister of External Affairs, policy interventions for mainstreaming again Department of Food, PD and BA and FW. So there are many people, many ministries, many units which are taking part in making this International Year of Millets happen. And I think even in ICAR, almost all the units are institutes are participating in this and taking up various activities in promoting millets, their awareness, promotion in consumption and utilization. So millets, they're really climate smart foods, and growing production, consumption of these millets will help in achieving the sustainable development goals 1, 2, 3, 6, 12, 13, and 15. So thank you all for sparing your time and listening to it. Thank you.
Yeah, thank you, ma'am. It was an excellent and long talk. So I request all the participants, if they have some query, they can ask directly, or they can put in the chat box. Actually, there are several messages for congratulations, ma'am.
Thank you.
Many of them
Thank
are
you so much.
congratulating. Many of them know you also, because they are asking how ma'am will talk, because she has been selected as director, so she joined.
Actually, I have not yet joined. I have to add to join because I need to take relieving from council. So I'm just waiting for the relieving. As soon as I get the relieving order from council, I'll be proceeding to Hyderabad to join. And thank you all for your affection. So any doubts or any clarifications? I'm sorry, I had a very bad throat.
Ma'am, one Vinod Kumar from JNK, he is asking anti-millet varieties which is suitable to grow in heavy soils. Any millet variety which is suitable to
Okay.
grow in heavy soil, that he is asking.
Right.
JNK.
Because millets, I can tell very confidently about pearl millet, it doesn't perform well in heavy soils. It comes in sandy soils. Even sorghum also in dry tracts only. Most of all the millets, they perform well in poor and light soils. Right now, I don't have any information. Maybe when I come across, I can share.
Okay, and he is asking that even in black cotton soil, whether any variety is there?
Yeah, that's what I understand. Madhya Pradesh,
Okay.
there you have this heavy black cotton soils.
Okay, ma'am. Ma'am, one question from ICR Kazri Leh, Mohammad Raja. He is asking what are difference between fine grain and coarse grain?
Fine grain, those rice people can. Maybe I need to come out with a very clear-cut definition of coarse grains and fine grains. Right now, you may excuse me. Yeah.
Hello, ma'am.
Anji?
Myself, Dr. D.K. Payasi.
Okay.
I am associated in linseed research, flaxseed research at RAR, JNKVB RAR Sagar.
Okay.
My concern is why we are not popularizing coarse millet, especially coarse millet and minor millet at Madhya Pradesh. The seed availability and package and practices of small millet is the major problem. Last year, actually, I am running a group of farmers also for promotion of different technologies to the farmers and research availability of research. Then I find out that seed availability and package and practices, especially application of weedicide to manage the weed, is the major constant in promotion of area expansion of minor millets.
Thank you, Dr.
So
Payasi,
it is
for
my
your
humble
input.
request for,
Dr. Payasi, the package of practices,
yes, ma'am.
cultivation of small millets is available on the website of IIMR. If you visit that website, you'll get the information recommended package of practices. Okay.
For
Seed
Odo
availability
and
is an
Kutku,
issue.
I think it is not available. I will visit and search out.
So if it is not, then join and ensure that it will be put on there. Okay.
Sure, ma'am. Thank you very much,
Yeah.
sir.
Welcome.
One question is how to reduce rancidity of pearl millet for storing cookies, from Dr. Vikas Pawar.
Right now, the storability of pearl millet flour is being increased to 6 months. There is no provision that you can store the pearl millet cookies for quite long time like other biscuits. Because the inherent problem of rancidity is there, you can store them up to a couple of months. Technologies are being developed, and recently the technology developed by IARA, from IARA, the Division of Biochemistry, they have come up with some technology taking up some thermal treatments and infrared treatment. They have increased the shelf life of the pearl millet flour to 6 months. Slowly, the technology will develop and it will be passed on to the industries. So right now, we cannot store beyond 2 months for the cookies.
Madam, among the millets you have mentioned, no, madam, which one is better for reduction of obesity?
Kindly speak loudly. Your voice is not audible.
Which millet is better for any one, madam? Which millet among the millets, whatever you have told, no, madam, which one is better for reduction of obesity, madam?
Ma'am, almost all millets are good, depends on the availability and how your body reacts to it. Some people are very comfortable with pearl millet. Some people are very comfortable with sorghum. Are you speaking from Hyderabad? Then people around in Hyderabad, mostly they consume jowar.
Yes.
So it depends on the condition, ma'am. You cannot say, because right now I have showed you in my presentation different millets and different patterns and availability of different fatty acids, amino acids, then carbohydrates. So you need to see, depending on for which purpose you are doing. Obesity, you should see those foods which are having good fiber, less fat. So see those grains and then take them.
One more thing, madam. In your presentation, that the table you have given, no, madam, comparison with paddy, wheat, and all that, iron, zinc content, all that. In that, in finger millet, you have mentioned the iron content that is 364 something. Is it?
I don't think, maybe a mistake, because iron content is very high in pearl millet. Okay, ma'am.
Okay.
And right now, someone also talked about coarse cereals. You might have heard in the budget, the finance minister, Union Finance Minister, Madam Nirmala Sitharaman, has specifically mentioned that these millets are now called as Shri Anna, means good food, because they have good properties of these nutritional and nutraceutical properties, and they are functional foods. So they are now named as Shri Anna. That's why she has mentioned them Shri Anna Jawar, Shri Anna Ragi, Shri Anna Bajra. If you remember, in the union budget when she was presenting. So from now onwards, these millets will be called as Shri Anna.
Okay, madam. Okay, thank you.
Ma'am, Dr. Sasikala, she's asking normally for how much duration we can restore permanent floor storability.
Madam, there is no problem of storing with pearl millet grain. The issue comes only with the pearl millet flour. If you are storing the pearl millet flour with at high temperatures and high moisture, then the onset of rancidity is very fast. But if you store pearl millet flour, after getting the pearl millet flour grinded, if you shade dry it and then add a little bit of salt and store it, the storability of the pearl millet flour without any problem, it can be there for about 3 to 4 months. That we have seen in Rajasthan.
Okay, madam. Thank you.
Welcome.
So now there is no question in the chat box. So if anyone wish to ask, they can ask directly also. And if not now, if they have further any queries, so they can mail to ma'am. So means she can respond letter also. We'll circulate the contact mail ID to all the trainees participants. Okay. So so ma'am, so so it was a very excellent and wonderful talk you delivered to all the participants for the nutraceutical importance of millets, the functional food today, which is going to be food of the future, because the health crisis is happening all along in the India and across the world. So millet will gain very much importance. So thank you very much, ma'am, on behalf of NDPGR and on behalf of training organizer and participants. I thank you very much for accepting our invitation and delivering such a nice and wonderful talk and enlightening the knowledge with very vast knowledge about the nutritional importance of the millet. Once again, thank you, ma'am.
Thank you. I thank the organizers for giving this opportunity and this platform to share the information. Thank you so much. And all the participants to include millets in your diet.
Sure.
Thank you
Okay,
very
once
much,
again, ma'am,
Thank you, ma'am.
congratulations.
Thank you so much.
Congratulations
Thank
and
you.
gratitude, ma'am.
Thank you so much.
Thank you, ma'am.
And
Thank you.
best wishes, ma'am. We will come back to Delhi again after serving the director job. Okay.
Okay, thank you.
Okay, thank you, ma'am.
Bye.
So, dear trainees, so now we have break for some time. So our next lecture is at 11 o'clock.
Experimental design for PGR evaluation. Today, among us, just Dr. Hanuman Lal is a principal scientist. He's from National Bureau of Plant Genetic Resources, New Delhi. His discipline is agriculture statistic, and he's a national network coordinator in All India Coordinated Research Network on a potential crop. And he has done his BSc Agriculture from Rajasthan Agriculture University, Bikaner in 1962, and MSc and PhD from IRI, New Delhi during 1994 and 1998, respectively. And in MSc, in PhD, he has worked on biometrics in statistical genetics. He has a vast experience of research, teaching, and extension activities in underutilized crops of more than 25 years. And he and his associates developed 6 varieties of different potential crops, which has been released. And he has more than 170 publications, which includes research paper, technical bulletin, popular article, etc. Now I'm handing over to Dr. Hanuman Lal sir for his presentation. This is a very important presentation from PGR evaluation perspective, and for designing any experiment before starting your research work. To you, sir, Hanuman sir.
Thank you, Dr. Subhas. So just now I'm sharing my all the dear participants and Dr. Subhas. Now I'm presenting my kind of the lecture. So I am sharing the slide. So the Dr. Subhas and our participants, our seniors, are joined this kind
Please
of
presentation
program.
mode.
Yes. So now is presentation mode.
Yes.
This is visible.
Yes.
So dear friends, this is an experimental design for PGR evolutions. So now next. So just I want to share some points. Is a very important. This is what is the statistics or distrust of the statistics. So before this, you know that according to Bowley, the statistic dangerous tool in the hands of those who do not know its use and deficiencies. So this is very important points. And statistics is a more useful servant to those who understand the proper use. So just I kind of discuss about my kind of presentation before I give the example of the misuse of the statistics. The heart patients after bypass surgery, the patient asked the surgeon, what is the percentage of my survival? The surgeon told the patient 100%. When heart patient, how I read in newspaper that 10% people are survival after the bypass surgery. The surgeon also told the patient, yes, I also know these things, but you are the 10th person for my bypass surgery. In my operation, already 9% has been died by the bypass surgery. So that's why you have the 100% chance of survival. This is total later the patient has gone. So this is a very simple. Why only this is leading? That there is a sample size very less. Only 10% and people can decide your result. So this is next. Next point, why conduct the experiment. So this is a very important to explore a new technology and new crop and new areas of production, to develop a basic understanding of the factors that control the production, to develop a new technology that are superior to existing technologies, to study the effect of the changes in the factors of productions and to identify the optimal levels, and to demonstrate the new technology to growers and to feedback from and their use about the acceptability of new technologies. So now, to experiment designs for the PGR evaluations. So this is what logically. So just before detail I presentation, just I some few points. So this is required the basic fundamental of our design of experiment. So this is experiment in which the degree of uncertainty, with which the interferences drawn by the is well defined. This is design of experiment. This is experiment classified in 2 categories: the absolute experiment and comparative experiment. Absolute experiment means this is only determine the absolute value of the some characteristics, like the average intelligence questions of the group of people, and finding of the correlation coefficient between 2 variables in a variate in distributions. So this is simple value just show. But in case of the comparative experiment, they are designed to compare the effect of 2 and more objective on some population characteristics. For example, of the comparison of different manures or fertilizers in experiment. So this is a basic concept of the fertilizer. Why? So this is the experimental designs is come under the comparative experiment. Next is some points here, terminologies are used in the designs, especially treatment. These are various objective comparison and the comparative experiment are termed as the treatment. In a field experiment, different fertilizers or different varieties of the crop on different method of cultivations of the treatment or study. You see, experiment unit, the smallest division of the experiment material to which we applied the treatment, like a block. This is very important, how to make the block in the experiment design. So we divide the whole experiment in the relatively homogeneous subgroup on traits which are some more uniform among themselves than the field as the whole. So this is known as a block. Yield, this is a characteristics, though you are recorded in the field. This is a yield. I think another point is a very component where is the experimental error. The experimental error, how to minimize, or what is important of the experimental error? So error is caused by the external factors which are beyond the control of the human process. This is known as experimental error. This is not in our hand. This is, for example, germination of the seed, plant growth, number of the pods, year per plant, response of feed by so many examples. There are factors beyond your control. So all such factors add toward the experiment. So all type of the external variant due to the inherent variabilities in the external material to this treatment are applied. So this is because the lack of uniformity in the methodology of conducting the experiment in order to word failure of the standardized experiment techniques and lack of representative of the sample of the population under the studies. So these are the experimental error. So this is how to control the experimental error. So I will tell the next. This another point with precision. What is a precision? Any experiment you conduct, so how level of the precisions are required. So very simple, the reciprocal of the variance of the mean is termed as the precision of the amount of the information of the design. Where is the experimental replication times of precision is inversely proportional to the error, variance of the means. So this is how to compare, suppose if two experiments are conducted, one experiment at design 1 and design 2. So which are efficient or those are not efficient of the compared to designs. So these are the design, consider the based on the variance. Suppose this experiment have the number of applications large. So this is the plot, a small homogeneous plot. Suppose one experiment have the small homogeneous plot, one other have the large block, the heterogeneous block. This is less efficient as compared to other design. Another piece of terminology is very important. Uniformity trials. Uniformity trials. This is a very important. It is in a field there is no uniformity areas there. The fertility of the soil does not increase or decrease uniformity in any direction, but is distributed over the entire field in erratic manner, not uniformly. So in such a case, the uniform trial enable to have to idea about the fertility varies from the field. So this is very important. Fertility trials are conducted. This is very important. Next, how to any experiment design conducted. So some principles of the experiment design. As a professor R. Fisher, the pioneer is the study the experimental design with a classical book. That this gives the basic 3 principles. This is a very good principle. The first is replication, randomization, and local control. This is a very important point. The replications and randomization both are the validity, estimate the validity of the estimate of the error. But replication and local control, the minimize of the error. This is a basic principle of the design. The first principle discuss about the principle replication. This is a very important replication. Again, it reduced, it's help in the reduce experimental error, or it's also to give the more precise estimate of the treatment effect, or how to kind of estimate of the kind of precision of the experiment is directly inversely proportional to the square root of the replications. The number of replication is increases, the precisions are increases. What are the factors are responsible to determine the number of the replications? This is very important experimental design. The extents of the precisions are required. How much precisions are required? What percentage are required? Another point is that the heterogeneity of the experimental material is there. So you have to make a number of blocks is more. Number of blocks is more, the homogeneous blocks are there. So this also the number of replication are required for this maintain the homogeneity of the experimental material. Very important, availability of the resources. Availability of resources is very limited, so you can sacrifice of the precisions also. the size of the experiment unit. Suppose a large size experiment unit, so you can't maintain the homogeneity of the material and uniformity type. Required a degree of freedom of experiment. The actually any experiment are required, the minimum 12 degree of freedom are required. So at least the to maintain the error degree of freedom of the experiment. The second principle is very important, the randomizations. The randomization, the allocation of treatment to experiment unit in such a manner that experiment unit has equal chance receiving the any of the treatment. This is called a randomization. So randomization is very important because it eliminates the human bias. Oh, this is very important. And this is also considered device effectively used make the experimental error independently. The third principle is very important, local control. कि suppose हमारे experimental area is not homogeneous, heterogeneous. So how to make the block and in homogeneous and make a strata, make a blocking in such a way that each strata should be homogeneous. So this is very important. The process of reducing the experimental error by dividing the relatively heterogeneous experimental area into the homogeneous block. So this is very important. This is not a local control. A basic experiment designs. Details I don't tell that, but some I will tell small information about there is a two classes: experimental design, a systematic design, or this is another randomized designs. The systematic design, there is no any restriction. They are choice as per your according to your choice. So this is the fixed number of times are as assigned together, adjust experiment is sequentially as per your choice or as per direction. So this is very important. Here you can see we can't rule out the possibility of the personal biases. Or systematic error are also introduced due to the correlation among the adjusted experiment plot also. So these are the different, and it is not possible to have a valid estimate of the variance, not as a no probability is involved. The make the analysis experiment data is meaningless. So this is not simple. But some advances also, according to your choice, there is an easy operation, particularly in crop experiment. The experimenter to make an intelligence placement various treatment to the experiment unit. The systematic sampling of experiment area easier, better, and chances of drifting in the influence of the one treatment over the another are reduced. Next, you randomized design. So this is the randomized designs. This is based on the principle of the experimental designs. The depend on, suppose some designs are depend on the two principles, some of designs are depend on the three principles. So this is available. So first one by one I discuss here. The CRD, RBD, LSD factorial. The first is a completely randomized design. CRD is a very simple design. The experiments of the randomization replication, this is only two principles: randomization, replication. There is no local control. Because this experiment is allocated randomly to the experiment unit over the entire experiment unit. It's very simple, it's very easy. Layout is also easy. Our design is very flexible. Any number of treatment, replication or different replication may be. The replications are equal or replication are not equal. Both the it can be possible. So this is a statistic analysis, very simple as compared to other designs. The missing observation also easy to can handle the kind of situation. It is very difficult to find the homogeneous experiment unit in all the respect. So it is a kind of very less suitable for the field experiment. It is only acceptable in the lab experiment. So this is a complete randomized design, most useful for the laboratory techniques, methodology studies, physics, MSc, and chemistry and cooking, some both biological experiment is there. So this is a very simple example is there. The equal replications are there. The total, this is 8 total experiments are conducted. 8 genotypes are allotted in 3 replications. The anomalies series only 2 component in variance. The total source of variation only 2 parts, only treatment and error. So this error part is very high. Next is the randomized block design. This already from field experiment are using these designs. The whole experiment area is not homogeneous and fertility gradient is only one direction. So there is no interaction between the treatment and block here. So this design is based on the three principles, especially all the three principles is flexible, readily adaptable, easy to analyze and point already. Blocking rate is the sum of square of due to the experimental error. There is no restriction are placed on the number of treatment and number of the replication. It depend on your availability of the resources. But error mean square for RBD as compared to the 60% this way. So RBD is more, the equal efficiency are required. So 10 replications are required in CRD as compared to get the 6 replication in RBD. So this is, but it cannot accommodate a large number of treatment. This is drawback of this level. Because in this situation, homogeneity groups are blocks are always geoparty. So in many situations, the criteria for blocking and grouping is not easily selectable. So this is say some one layout of the 8 treatments is there. The first replication randomized given here, allotted the treatment randomly. The second replication is a separate randomization take place on third. On the basis of this only the source of variation divided into the 3 groups. The replication, treatment, and error. So on the basis of the identify the standard error of the difference on the mean and critical difference under a selected method. Next is the factorial experiment. This is an example of the 2-factor RBD. Suppose 2-factor RBD. The total work is suppose A or B are 2-factor. So A or 2 are different factorial. So suppose A is a level or B is a B level. So this is a totally RBD total factor. So here is the 4. This A factor is a 2 level. The example is given, and B factor is a 4 level. The total 8 treatments are allotted the first replication, and second replication, and third replication. So this is simple ANOVA of this factorial experiment. So this is also used for the factor experiment, especially in the agronomy experiment and different biological experiment. So this is a different way how to kind of comparison of the treatment of that is experiment. Next design is very important. This is the Latin square design. The whole experiment area divided in especially of the M square experiment. This is square, perfect square. The arrange in a square so that each row and as well as each column treatment in M unit block. But especially the very important, okay, how to allot the treatment, how the randomization there in this experiment design. The M treatment are allotted randomly to in this row and column in a such a way that every treatment occurs once and only once in each row and each column. So this is such a layout. Suppose here the 5 treatment is here and 5 row and 5 column. Only one treatment occur only 1 row and 1 column. So this is a basic criteria for this design is as per the highly efficient as compared to other designs. But is the conduct experiment of the M plot are equally area associated treatment, different fertilizer and different irrigation and fertility. But very important, LST is suitable only to treatment not less than 4 and not more than 8. So this is drawback of the very important. Suppose there is a limited number of genotypes are tested, so this design can be useful for this special. So LST normally used for the experiment to remove the heterogeneity of experiment in a 2 direction. So this is a very good kind of how to make a homogeneity in both the 2 directions. Eliminate the American heterogeneity in the 2 direction. On this basis, this ANOVA, this is source of variation divided in different kind of component. The row wise, column wise, and treat and error component is same. So this is important for this design you can apply in the field experiment. Next, this is very good split plot design. This split plot design and factorial device the same way. This is different only. This is only split plot designs are block experiment. The block themselves serve as an experiment unit for the subset of the factors. This is a suppose, for example, the irrigation treatment within the replication are put together in a large plot, the called main plot. So it is easy to irrigation of the main plot. So application is also easy. And the split plot, the factor that assigned to the main plot is called the main plot factor. So in such way, the main plot is split into a smaller plot assigned to other factor. The small plot also called as a subplot. The factor assigned is to calculate subload factor. The main factor is a block for the subload. So this is different in a factorial experiment. The field of operation is easy and precision in the estimate of the main plot is less than the factorial. In this experiment, this is the precision, especially of all the factors. Both the factors and interactions are equally important in a factorial experiment. When in split plot design, only the kind of subplot is more efficiently estimated. So this estimate of the main plot is less than the factorial RBD. The precision of the estimate subplot factor interaction is more important, more than the factorial RBD. So this is a difference between the factorial experiment and split plot design. The field capabilities, the treatments of which are required more precision should be assigned a subplot. This is a, for example, of the 4-level effect and main plot and 4-level of the B as the subplot. Here you see here, sir, suppose this first replication, the A1 is this is a main plot. This is a main plot. A1, this is A2, this is A2. So randomization such a way that one like B1, B2, B3 this is subplot of this main plot. So this is a way of the layout of the kind of split plot design. Next, this is important how to kind of source of variation distributed. The replication, there is two part of the error, the replication, the vector A, and this is error component. The second part is a B component replication, the error component one. This is error for the main plot. This is an error of the subplot. So on the basis they are study and analysis and different critical differences calculated for the identify the treatment. Next, another component is very important, split plot design. This is another point. This design is only apply on 3 factors: the main plot, subplot, and subplot. So 3 level it is. So this is 3-factor factorial experiment with a particular randomization of treatment. In this experiment, treatment which require large area assigned to main plot, then treatment require the intermediate, and this is assigned to subplot, and treatment that require the least area assigned to the sub and subplot. So this is a 3 stages. This is a kind of randomization is there. So these subplot are blocked for subplot, and main plot are blocked for the subplot. In this case, only the precision estimate is highest in the subplot. The last unit is a precision is the highest, on intermediate in the subplot is your and lowest in the main plot. So this is the advantage of this kind of. So these replications by the allocation layout in situation this is a one. This is a main plot. This is the one. What is the main plot? This is a subplot. A1, this is a pura A1. This is only subplot. And again divide this in this again portion. This. Therefore, 4. This is a sub and subplot. So this is the kind of split plot design. So this is a proper layout. This is the ANOVA, the bifurcate of this is the error part on this is 3 error: the main plot, the subplot, and third error sub and subplot. So this is the experiment. Next is very important, group balance block design. Suppose you want to test the experiment, the different group. Suppose some high yielding, different hybrids and local varieties. So you can make a group, and group you can make and allocate the different. The randomization take place the one separate. Suppose if one group is a separately a randomization, so we can say total suppose to 27 genotype here. So 9 genotype, one type of the one group. That's the next 9 is a second group, and third is third group. So you can allot the first replication. The randomization is separately for separate group. So this is a group balance design. Then group balance design layout is here. The first replication, second, third, and fourth replication. The treatment belong to the same group are tested more precisely than the treatment belong to the different group. So as the treatment of the same group are tested in the same block, and other group are tested in the different block. So this is a way to how to ANOVA develop. So this is a source of variation. So first is a group of error part is also divided in two parts. The group one, the group A and group B, the different possibilities there. So this is the NOI is completely make. Another thing, just all the designs have some limitation, some importance, or on the availability of the resources, we can apply the design. But in suppose in case like a design in RBD is less efficient than when number of treatment increases due to the increase in block size. So such a situation, how some design should become. So this is a very important for this. For experiment, so which is a large number of the treatment, like incomplete block design with more than one block per replication are adopted. So the homogeneity of the experiment area also depend on the condition. So this is, for example, the irrigated transplant paddy experiment. The homogeneity can be expected over the large block, but in the rampant upland rice, a large block is expected to be the less homogeneous. So in such a situation, so how can I adopt some design? So incomplete block design is more appropriate than the complete block design. So in situation, so on the basis of the incomplete block design, the different type of the incomplete designs there, the balanced lattice square design, partially lattice square design, or partially this also, which do not form a complete for replication. That this is with the replication or without replication. Balanced incomplete block design, partially balanced incomplete block design. So these are different type of the incomplete block designs there. But is a limit. This is the importance that large number of treatment can be evaluated here. This is the first example. I can consider the balanced lattice design. So this is a very important, the complete replication. This is required for highly precision. How to complete replication? So here this suppose the basic feature of the balanced lattice square design. The number of treatment are perfect square. This is a very important feature. Key number of treatment perfect square. The number of treatment per block. This is a block size K or square root of the number of treatment. This is so this is the importance of K treatment. And number of replication is more than the block size. So this is a R is important, R equal to K plus 1. Suppose an example here is the 49. The treatment are tested and evaluated in the field experiment. So this is a total, the whole experiment. So 49 means 7 into 7, 7 square. So 7 is equal to, so one replication have a 7 block. This is a 40. The 49 treatment allotted randomly in first replication. Then again the 7 block. So total 56 blocks are prepared in such a layout of the experiment. So this is the basic feature of the balanced lattice. This is a highly efficient design. But resources are the very costly because the number of replications are required. Suppose 49 treatment are evaluated, so you have to actually approximately 8 replications are required. So some this is a limitation is there. Next is this is a very important partially balanced lattice square, which do not form a complete replication, not required of the like a 7 treatment and 8 replications are required. The basic features in this design, the partially balanced lattice design, this is very simple lattice square. Suppose you have only 2 replications, this is simple lattice square. There are 3 replications, the triplet lattice square, lattice, and this is a 4th the quadratic lattice. So this is a different. So some parameters and some conditions are required. If a number of replication, even number of greater than 2, the basic plan can be obtained from the any 2 of the following options. So this is a, suppose R replication. So here is only suppose your test is 9 treatment. The 9 treatment first replication 3 block and second replication are 3 block is 9 randomization here and 3 is also randomization here. So this is important. But in case suppose this is another case the partially balanced lattice design with repetition. The same first allocation randomly, first is a randomization cycle, second also replication based on randomization, like a third and fourth are repeated. The same repetition, the same replication, but replication there, but same T1, T2 same and T1, T2, 3 like. So this is repetition of the replication. So this is a way layout of this simple lattice square. and repetition of the replications. So this is important. So this is a limitation, but some information is also loose as compared to the balanced lattice system design. When balanced and complete designs is another feature. This is a very important. In complete designs known as a balanced and complete design is satisfy the following conditions are required. The number of treatment occur more than once in a block. This is a question. Each pair of treatment occur together is the same number time. This is a lambda treatment. Suppose this is one block is there. So this is a total 11 blocks are there. So total 11 treatments are allotted. This is one. So this is one replication, two replication. This is a way. So second, the randomization, third replication. This is the way. So this is the design of AIBD 11 treatment and number of replication and number of k is equal to 5 and lambda. So suppose two block is a first and second block, only two treatments are common. That so for the 4 and this 4 and 5 or 5. That this is a problem. So this is a kind of limitation. How to? So this is a layout of the balance and complete design. Next is in PGR system. The argument design is very important design as compared to other design. All the designs are show the, but there are some limitations, some different designs are there. But argument design is very important, usually PGR evaluation system. So this is initially this genetic resources environment is earlier this. So some of the times suppose in experimental explorations team is given, so some new germ class and superior selection. How to can identify this genotype best as compared to existing varieties? Suppose हम check varieties there, हम collect the material different kind of exploration. How to compare that this is the best kind of materials to select from as compared to check variety? So this problem is this evolution study is the quantity of genetic material collected from the exploration tree is very limited, or cannot be made available since a part of this is to be the deposit in the gene bank. So available quantity of seed often not sufficient for replication try. So this is a unreplicated try. So this time suppose the number of new germ class and some cultivar were collected to be tested in very high like the 1,000, 2,000, sometime up to 3,000 accession. So it is a very difficult to maintain within the block homogeneity. This is very important. So these type of the situation were come to know the federal in 1955. The screening the new strength of the sugarcane and soil fumigant used in pineapples. This is a argument designs. The designs are introduced at the federal 1956 to fit the need arising screening new strength of the sugarcane experiment station. That Hawaii, especially this is so argument design are available different way. 0 way, 1 way, and 2 way. This is important. The eliminated heterogeneity of the setting. The augmented design eliminated heterogeneity in one direction is called augmented block design. Suppose the heterogeneity is eliminated in two directions is called the augmented row and column design. So this is simple. Only 0 way means it's only augmented design, and 1 way. So this is important augmented block design. And heterogeneity can eliminate two direction, row and column. So augmented design is very important. This is row and column design. Of how to lay out, this is a augmented design. Suppose some one example is there, this experiment. Total, this is here is only 7 test entries and 4 checks are evaluated. This is a very small example, not. So in this, how to make a block? So there is I make a 3 block. The check are randomly allotted in the 1 block, and remaining kind of left kind of vacant kind of experimental unit, the experiment kind of test entries are allotted. In next block, also check are randomly allotted. The remaining kind of left kind of this is a vacant kind of plot is also allotted remaining test entries. So likewise, same is repeated in the next block. So this is a way how to can allot the treatment in the blocks. Essentially, how to ANOVA. This ANOVA is a kind of different kind of block whether. So this is a kind of calculation the different part of these designs. Only there is a 4 treat the how to comparison the treatment. So there is 4 errors are calculated, especially how to compare. Suppose you are compare between the only two controls. So then say error 1. This is calculated. Same thing. Suppose the comparison between the two test entries, the error 2, and 2 test entries not in the same block. So this is error 3, and between the kind of test entries and control. So this is the error 4. So on the basis of the kind of standard error you are calculated, and critical difference also calculated as well. The 4 CD are calculated here and compare the treatment means. So this is a way how to play out of the experimental augmented design. In case of the augmented block, one direction, suppose same one block and one row and column 2 direction also is follow as per the latest Latin square design. This is very all the treatment and design of experiments, some diagnosis and remedial measures in the field experiment. Some situations, some problem is come. So how to diagnose this is a proper, and how to maintain or how to remedial for this kind of problem. So this interpretation of the data based on the analysis of the variance is valid only when following objections are the satisfied. All experiments, suppose all the experiment. So this is a very important for the subset. First is the additive effect. The additive effect, the treatment effect and block effect are additive. This condition are required. Next, independent of the error or experimental errors also independent. This homogeneity variance is also important. This is also homogeneity variance are required. These also errors should be normally distributed. So these assumptions are required of the experiment. But how to work, everything not possible, depend on the making the blocking and different experiment allotted. So some, for example, I say this additive effect. They see your example here, the 2 treatment tested and 2 replication. Here you see the treatment effect is 20 and 20 and replication effect and 65. So these are the additive effect. But in the case of the second example, this A or B and 2 replications are tested. There is there's a difference. One there 40 and 25 block effect. The replication effect is only kind of effect 60 and 60, 75 and 60. So this is a difference. So this is a difference effect. So this is a not kind of additive effect. So how to eliminate the additive effect? So this is the effect 2 factors non-additive. So then the logarithm is quite suitable. So these data transformations are required. So in such a way, the data transform here. Again, this taking the logarithm values are given a bracket. This or this. You can say this is actually this is a difference. This is a no difference block 25 and 20. This 60 and 60. So this is the additive effect. So this is transformations are required. So somehow to determine the one test is static tests are also this in RBD 1949 are applied to test that effect are additive or not. So this is a another point is independent of error. Dusra homogeneity variance and normality are generally violated together. So how which tests are required? How to know this is independent of error or not? So in this situation, the test of validity of normality of the errors for the character under the study, so we can help of the surface the normal probability plots, Anderson-Darling test, the D-Augustus test, and so those are different tests are there. You can adopt and identify that this is a errors are independent or not. Another point to how to variance are homogeneous or not. Homogeneity. There's a crude method is also there. The simple you plot the variance or error. So you share you can see the here this is pattern of this distribution of the error. So this homogeneous variance. Another way variance is you see the data. Second example, the heterogeneous variance where the variance is proportional to the mean. But you clear-cut idea is here the heterogeneous variance without any functional relationship between the variance and mean. So this is how to identify your experiment. This is a homogeneity of variance, or not, it is present or not. Another is a good method also is very, the Bartlett chi-square test is very important for homogeneity test of the variance. This also can apply and test this. Of how the remedial measures, different measures ki aapko the data are normality is there, error is normally distributed or not, additive effect is there or not. So this is the remedial measures for in experimental data. So data transfer is the most appropriate remedial measures because common transfer scales apply to all the observation. The comparative value between the treatment are not altered and comparison between them remains valid. So transformations variance should be satisfy the following condition. After transformation, the variance of the transverse variance should be unaffected by the change in the mean. And this is also called the variance stability transformations. This is also condition. It should be normally distributed after transformation. It should be one for which effects are linear or additive. The transformation scale should be such a for which a arithmetic average from the sample is the efficient estimate of the two means. So three transformations are mostly widely applied in biological research or your data. This is logarithm transformation, square root transformation, or sine angular transformations. This the different this is way are given. So this is a very important. For example, logarithm transformation. Already give the example. So in this, the variance proportional to square of the mean or coefficient of variance is a constant where effect are multiplicative. So this is not additive. So we apply the logarithm transformation. There's some example like measurement, the length of the external growth, weight of the tree, number of insect per plot, number of egg mass per plot, some type area, the subtype data is given. So you applied the logarithm transformation. So some way, this is a way of the transformation, some formula is there. This automatically can software transfer the data. The transformation should make the error normal. When observation follow negative binomial distribution like in this case. So this is an insect count, especially experiment, the plant protection experiment. So especially this is an observation. All the data is follow the negative binomial distribution, not a normalism. So in this case, we especially apply the logarithm transformation data. Another very important is square root transformation. This is also same procedure. The variance proportional to the mean. This is square of the mean proportion. Where is a variance is proportional to the mean, then you apply the square root transformation. So this transformation, the data are given in the percentage. Some of the example of a number of insect causing trap, number of weeds per plot. This is a different type of this. So the data is set generally follow the Poisson distribution. The data, especially our Poisson distribution follow. So in this case, the square transformations are required to the and convert the Poisson distribution to the normal distribution. So some way to apply this transformation here. So this is from these transformations are appropriate for percentage only data. Very important. The range is between 0 to 30 or between the 70 to 100%. Next is sine angular transformation. This important when data this transformation are required. The transfers appropriate for the data are on proportional data, personal. So this data obtained from the count and data explained decimal fractions and percentage. So such type the data generated from the experiment and different. So this data is followed as a binomial distributions. So binomial distribution that convert to the normal distribution. So sine transformation, the binomial distribution to normal distribution convert. So this is the sine inverse transformation apply here. So this is a transformation of the data. This some of the informations are there in this experiment. Some error part, some normal assumptions are not follow the experiment. Then data transformation. Next, suppose your data in RBD and other kind of LSD, all designs are there. But there is a very difficulty to maintain the homogeneity in a field experiment, especially. So how to suppose you generate the data, after generate the data, you show that the data is not follow the assumptions. So this is another test available for the experiment data. How to our inference are found out. So in conventional setup, the analysis experiment data is based on the assumption like a normality, independent, constant variance of the observation. So there may be the exercise experimental situation sense, particular normality may satisfy. So situation we only rank 6 only R does generate and in the rank according to their magnitude. So data rank use the non-parametric. So this is a very advantage of the non-parametric statistics, the distribution field. There is no need to report. Our assumptions are required. Easy to calculate or simple to explain and understand. So this is very important for this non-parametric test. Non-parametric test procedure for analyze the one way and two analysis and classify data like RBD and CRDs. So some these processes, suppose a crucial Wilkins test very important in CRD, and Durbin test is a very important RBD. Agar data can after the you show they not maintain the homogeneity. Agar large number of treatment are tested in the so 25 more than in RBD. So then you can also apply the non-parametric test for getting the inference from this comparison of the treatment. Next, the different tests are available. Suppose different means comparison between the treatment of the means. So this is very important. How to compare the treatment between the different. So she very simple. Already this is now the first list is quite different. This LS diffuser now is known as a CD. So it's a common all the design the CD calculated and comparison different treatment between the comparison. But now different tests also available. The DRMT is very common. SNTR is also there. Duncan multiple rank test is also there. Turkey honesty significant difference test there. Turkey Kremer test is different tests are available as per the your demand. Next, in germ class evaluations and any experiment, the pooled analysis over the year and location. This is a very situation come. Multi-location evaluation program in NPG are also there. So experiment conducted multi-location. Maybe different design, maybe RBD, maybe a latest design, maybe Egmont design. So how to pull the data or how to analyze it, how to compare the different kind of test entries in the location, the year, the environment. So in this situation, the experiment are repeated in different year and location. The result of the repeated experiment analyzed by the pooled analysis, combined analysis, various methods. So with the help of the pooled analysis, a consistent treatment over the year and location may be judged. Agar suppose consistency रहेगा, so this is a how to. Agar error should be homogeneous over the year. Error means sum of square may be homogeneous, may be heterogeneous over the location, over the year. So how can they pool? This is a very difficult situation come under our experimenter. So this is the how to. So this is the important key, how to maintain the homogeneity, how to test the homogeneity. So this test of the homogeneity error mean square across the location over the year. So this is the chi-square test is very important. The Bartlett test is chi-square test are testing. Again, suppose after the testing you can show the homogeneous. So then you make the ANOVA and complete the inference. So the pooled LHC homogeneous over a year, some example in the RBD. This is data of T treatment and this year by this year data are located and analysis. The source of variation, the year and replication are within the year and treatment. And this is about interaction between the treatment of the year. So this is a pooled error is also there. But in case of the T, treatment means kind of interaction, the interaction is not significant. So how to calculate the EMS? The interaction EMS and pooled EMS are pulled together. EMS get this way, the pooled analysis for the homogeneous experiment error. And different way the testing of the CD and standard error are calculated. Next is it very important how to the pooled analysis of the heterogeneous error means some car is not a homogeneous. So this is or the data here convert. And some transformations are required. So how to pull this support data not kind of error means some is not homogeneous, this heterogeneous. So how to make the kind of inference? So this is important. So we weighted analysis. So we complete the weighted analysis on the basis of the replication divided with EMS on the location wise. So some weighted are given here and the weighted convert to the new data with the can multiply by the different values and weighted analysis and adjust the treatment mean. So on the basis we calculate the different kind of ANOVA and make a kind of comparison to the treatment on the basis of the critical differences given here. So this is a way how to add multiple kind of testing of the zero class evaluated the different location and different our year. Next, now to can analyze is possible. The different statistical packages for the design and analyze experiment are available. Different SAS is a very important package. SP is a very old package there. The different design experiment also. Your ISRI is also doing the some statistical packages are developed. Open source is also available. So these are the different of the. So all the nutshell, all designs, all experiments I explained here. Thanks.
Thank you very much, sir. Dear participant, if you have any question, please post or you can ask from sir directly. Sir, we have one question from Dr. Anuj Kumar Singh.
Yeah.
Is augmented design can be utilized for two factors?
As augment design can be applied to factor. It is a अगर suppose आपका number of experiment अगर less तो you can apply it augment.
And sir, another question by Dr. Lalu Prasad.
But अब in first you decide कि suppose अगर का two factor तो which factor की combination you want to make a check. This is important in two factor. Next.
Sir, another question by Dr. Lalu Prasad Yadav.
Yeah.
Is there any software available free of for analysis?
Free of cost.
Yes, sir.
Free of cost is some in ISRI also a open source some software there. You are also use there. In one in HEU is very important kind of OP state is open source available. All the experiment you can analyze there.
Dear participant, any other question? If you have, you can ask.
I would like to inform the participants, Dr. Hanumanlal is also heading the, ECRIP potential crop. There are many underutilized crops where I hope you all are working. If you are interested to know about these crops or any kind of collaboration you are willing to make with Dr. Hanumanlal or our PC unit, you are all welcome. You can also ask questions regarding this also.
Any question? Okay, I think they are Sir, another question by Bangarema. This is I need information about window states.
This is also window state available, but not open source. You have to purchase.
Okay, sir. If no question, then I will give a vote of thanks. First of all, sir, I on my behalf and on behalf of organizer, I thank you very much for for delivering such a nice lecture on experimental design for PGR evaluation. And sir, you have explained all the experimental design in a very simplest way, and our participants have certainly benefited from your such a elaborative lecture on this year experimental design. Thank you very much, sir.
Thank you, Dr. Subhas. Thank you, Dr. Tripathi. Thank you all participants. Thank you.
Now,
Thank you very much.
Thank you very much, sir.
So now I unshare my slide.
Yes, you have unshared, sir.
Okay. Thank you.
Okay, thank you very much.
Thank you.
So friends, we'll get back again at 12:15.
But do not sign out your Zoom link.
Because that.
Thanks a lot. To begin with, let me thanks to the organizer, especially Dr. Kuldeep, who has invited me for these lectures, and hope we will be together for almost 1.5 hours or so. And let's see that how we can serve a little purpose of these lectures. So if you allow me, can I share the
Sure,
slide?
sure, sure, sure. Yeah, it's okay, sir. Fine.
So friends, a very good afternoon, and I hope most of you are from biological science discipline. So I'm here to talk, probably I think before me, the Dr. Hanumanlal Raga, my senior from ISRI, would have discussed a lot about statistical designs used for biological science or used for all kind of experiments, being in genetics or plant breeding, all kind of things. I'm here to again, as I said, to talk basics of statistical methods, especially for plant genetic resource data. In fact, uh, ideally would have been that I know what are your expectations from this lecture, but let me, and as a statistician, let me take it an average expectations is less like say a kind of an exposures to the kind of techniques available in the statistics or coming up emerging techniques available in the statistics to deal with the problems of the or data analysis of the plant genetic resources. Yes, to start with, I always say that the first thing, because now the statistics is a discipline which is being used in almost every discipline of the agriculture sciences or any another discipline. The first to, if I start, so first question is that why this particular lectures had been arranged for this training program, and then what are the methods of data collections, and what is the peculiarity of plant genetic resource data, and then I'll come to the scale of measurements, and then to begin with, let us describe the data, let's describe the statistics, and then a most commonly used tools for of a statistical techniques is correlation and regressions. And then since we deals with multivariate data, so generally we are using cluster analysis, principal component analysis, nonlinear principal component analysis, and then an exposure to the machine learning as well as artificial intelligence techniques. To be specific, we'll be talking on fuzzy clustering, NN for yield predictions, and then deep neural network as well as convolutional neural network for yield prediction. So, friends, if you have any specific questions before begin with, you can have. Otherwise, we can have in the end of it. Is there anyone who had used of machine learnings or AI techniques or multivariate analysis? Can I know anyone like any specific applications you have done in your research work? Or should I talk first for a few minutes and then I will come back?
Sir, I think delivery lecture first, sir.
Okay, good. So a very simple definition of statistics is that it is a branch of science which deals with collection, compilation, analysis, and interpretation of the data. The basic purpose of defining statistics in this way is just to make it simple that these descriptions helps me in explaining that why statistics is essential for every person who are involved in any branch of knowledge or any branch of research. Reason being is that whatever branch of research you are in or whatever branch of knowledge you are in, basically if you are collecting qualitative as well as quantitative data, naturally you would like to see, you analyze those data, and you will like to prepare your evidence on the basis of that data. So when it comes to the collection of the data, basically there are only two ways of collecting the data, either through design of experiment or through sample survey. There is no confusion. There should not be any confusion like primary data and secondary data. Whatever may be the data, either you have a primary data, you have a secondary data, any data. Data will be collected either through design of experiment or through sample survey. When it comes to the design of experiment, which you would have already had a kind of an elaborate lectures in the last 1.5 hours or so, basically the word itself says the experimental design. This means you are designing the experiment. This means researcher has a complete control on the experiment. So you are trying to create a controlled conditions, because what happens that most often you try to develop a variety and you try to compare the developed variety with the existing variety. When you are developing a variety, this means you are making some changes in your genotype. You would like to see that your variety is being compared only in terms of a genotype, and by taking control, creating control condition for all other variability, be it a soil type, be it a fertilizer dose, and all kind of weather parameters or whatever may be. So experimental designs is where researcher has a complete control, and they try to create a control conditions, and comparison is only between the genotype which you have developed with the existing genotypes. And how they create the control condition? They create the control conditions through principles of experimental design, and there are three basic principles of experimental design. They are randomization. Randomization is simply the way you are allocating your treatment to the experimental units. Now question comes that why do we go for a randomization? As a statisticians, basically we ensure that one of the basic assumptions of the ANOVA, when you see nothing comes as a free. So everything has a price. So ANOVA had certain assumption, and one of the assumptions is that observations are independent. So if you want that observation should be independent, then you must follow the randomizations. Then as a applied statisticians, I'll say that, or as a plant breeder, what you want that there should be a objective comparison among the treatments. In order to have an objective comparison, naturally you will have to go for a randomization. Otherwise, there is a question of a biasness in that. The second principle is replication. This means the number of units to be provided for each of the treatment. Why we go for this? Because we want to develop an estimate of the error variance. Estimate of the error variance. We are not reducing the error variance. Error variance per se is a population parameters. Anything which relates to the population is a parameter. Anything which relates to the sample is a statistics. So you cannot change the parameters, but you can always estimate an error variance, and you can increase the accuracy of the estimates of the treatment effect. And third is the local control or error control, where you increase the precision by choosing the appropriate type of experimental unit, or will as their groupings, while you do the blockings in the randomized block design, or you do the confounding in the factorial experiment. In all these kind of things are the error control or local control. So essentially in design of experiment, what the way you are carrying out the analysis of variance, because any data will have a variability, and what you try to do is try to assign the variability into two groups. One, a causable source of variations, which is you say which you can assign any cause for it, and whatever you cannot assign, that becomes a kind of an error terms into it. So total variability is divided into causable source, and then a kind of an error terms. Like in the life, whatever you do, if you feel you have done it, you generally say that I have done it, and the rest thing is the kind of a luck. So error is corresponding to the luck. And similarly, you try to talk about the covariance, any variables which is closely related to your variable under study, you try to use it, and you try to explain some of the variability of the data with the help of those covariates. When we talk of experimental design, I know that there are a lot of designs which should have been discussed. We start with the complete block design, where the block is complete, and completely randomized design, only design in CRD, where the local control is not being used. And then we go for a randomized block design where blocking is being done. Then we go for a Latin square design, and then we go for a large number of incomplete block design, be it a balanced complete block design, be it a partially balanced incomplete block design, lattice square, Latin square, all kind of things are there. So all these things we had been discussed with that. So this is one of the way of collecting the data, and most of the biological science people, they are mostly using experimental designs. Now even in a part of the social science, we go for RCT kind of things, but mostly we collect the data through sample survey. Sample survey, here the situation is completely different. Here population exists in its own way. You do not have any control on the population, and then since you want to study about the population, so since population is large and time is limited, you have resources limited, you try to collect your sample from a part of the population, and your objective is that your sample, part of the population, should be representative of the whole population, and on the basis of the part of the population, you try to infer about the whole population. But the challenge of the sampling is that how to select the sample so that you can make a reliable statement about the population, and to learn what kind of statements you can make. Like, so one has to be very careful that from which population you have selected the sample randomly. Only about that you can make, because most often what happens is that you study a kind of in a particular state, or you study a particular district, and you try to talk about the whole state or the whole of the country. So those are the some of the kind of the lapses on our parts when we try to do the sample survey. Of course, when we try to talk about the sampling technique, there is a random sampling, or I generally say about the probability sampling when there is some kind of a probability mechanism attached to it. And then we try to talk about the non-probability sampling or purposive sampling. When we try to talk about the probability sampling, we try to talk about the equal probability sampling. So a general conception is probability sampling or a random sampling is always a equal probability. No, not necessarily. Yes, random sampling, most often what we generally use is a equal probability sampling. This means each unit of the population is being included in the sample with an equal probability. But yes, we may go for a varying probability sampling, because suppose if you go try to go for a food distributions, and you know that there are villages which have got a larger in the size, so you want that the villages which have got more households should get the more allocations. So naturally in those situations we go for a varying probability sampling. Now, the only things which I want to make it very clear here is that why we are so often obsessed with the probability sampling, because in probability sampling, we try to study the biases as well as the standard error of the estimates from different sampling plans. So, suppose if some of your friends is asking that what is the price, what is the fare of Delhi Airport T3 to the IRI, you can have two answers. One is you can say that 500 to 550. Another thing you can say that 500 to 1000. It doesn't matter that both of you have said the 500. What matters is that how much margin of error you have attached. One is attaching only 50 or 100 rupees. Another one is attaching the 500 rupees. So 500 and 550, both have said 500 and 550 and 500 and 1000. So it's not the estimate which is important. It is the margin of error, the standard error. Or then how do you get that margin of error? You get through the standard error. And how you get the standard error? Only when you will select the sample through random sample. Then because some probability mechanism is there, then only you will have a certain distributions and you can find out. So it's not the estimate which is important. It is the margin of error. How wrong, how much margin where you can go wrong. That is important. You should try to. So in order to have how precise is our estimators, how accurate is our estimators, generally precision and accuracy we generally use differently in the statistics. Accuracy is related to mean square error, and precision is always related to the kind of a variance. So how accurate is the precision? So it depends on your margin of error. Now, coming to the basic of a statistic, when we try to talk about a statistic, the first term comes to variable. What is variable? So variable is a characteristic. It is a trait. It is an attribute. Let it in case of a germplasm, anything that can be classified or measured. Maybe stem pigmentation, maybe seed color, maybe seedling vigor, maybe seed per pot, plant height. They are all variable. Variable is any characteristics which in a given study may change, have more than one value. That's when it's variable. Otherwise, it's a constant. Now, when you have a kind of a variable, you must understand that whether it's a quantitative as well as qualitative. The reason being is that the techniques which will be used for analysis will be different, whether it is a quantitative variables or is qualitative, because a lot of statistical techniques are available for a quantitative variable, but when it comes to the qualitative variables, there are few, very few. So in case of quantitative, again, you have whether it's a discrete variable or it's a continuous variable, like seed per plot, either it will be 1 or 2 or 3. There will be nothing like a 2.5. The average can be 2.5, but as such the numbers, number of patents, number of publications, they are always a kind of a discrete number. But when it comes to the plant height, it's a continuous variable. Yield, it's a continuous variable. So what happens is that you keep on identifying that first, if you have collected a variable, let us first identify whether it is a qualitative variable or quantitative variable. If it is a quantitative variable, whether it is discrete or a continuous. So seed per plot pod is a discrete variable, but plant height yield is a continuous variable. Now coming to the qualitative variable, again they are categorical in nature, isn't it? So like nominal variable. Again in nominal, you can have binary and you can have multi-state, like stem pigmentation. Suppose yes or no kind of things, only two, or you can have more than. Then you can have, so ordinal, when you have a kind of, and there can be an order, like you a small farmer, medium farmers, large farmers. So there is an order in that. So then it is an ordinal, but you can have a kind of a red, blue, green kind of a color. They are nominal in multi-state. There is no order into red, blue, green. So you need to separate these variables. You need to separate that accordingly your tools will be different. Statistical tools will be different. That's why scales of measurements is very important for any data analysis. When I say nominal, this is the lowest level of scales of measurements category. You do not know anything, only you know whether stem pigmentation is levelable or not. This means it is a qualitative variable at a minimal level, only presence or absence of it. So, and then multi-state like seed color is there green, yellow, black, brown. So they are nominal as well as categorical scale, or sometimes you are dividing the population on the basis of gender, such kind of thing. Ordinal scale is there where you have a qualitative scale with order. Suppose if you say seedling vigor as a poor, medium, good, very good. Here you know that poor is less than medium. So you are not able to, not only you are able to classify it, but you can even order it. So is additional information you are getting. So the moment you move from nominal to ordinal, you get an additional information. And that's why when you deal with an statistical techniques, like if suppose if you have an only binary, then you go for a binary logic. If you have a kind of a multinomial, you go for multinomial logic. But if you have a multinomial and there is an order, you go for an ordinal logic. So kind of depending upon the type of variables, you use the tools. And then one is interval scales. Of course, interval scales only that you do not have it. In interval scale, you can do anything and everything. You can have a difference. Only thing which you cannot do is that you cannot take a ratio. And that's why when you have an year, suppose 2000 and 2010, so you cannot take a ratio of 2010 by 2000. It does not carry any meaning. But you can always take a difference of it. And the last scale where most of the variables which you are measuring, be it a plant height, be it a yield and all kind of things, they are ratio. You can calculate the distance also, you can order them, you can take a ratio of this. So whenever you are collecting the data, you must try to categorize those variables on the basis of whether it is a nominal or a categorical scale, or it is an ordinal scale, is it an interval scale, is it a why? Reason is that if it is a nominal scale like a stem pigmentations, then you cannot do all the statistics. What you can do is you can calculate the frequency, you can calculate the percentage, you can calculate the proportions, you can calculate, you cannot calculate the mean, median, but you can always calculate the mode. So there are three measures of central tendency which we will be discussing. Here you can use. Then you can have a coefficient of contingency. If at all, if you know that observed and predicted, so you can use the chi-square. But here you cannot use the correlation, regressions, mean, median, and all kind of things. But when you look for an ordinal, say seedling vigor, now here there is an order, so you can go for a median, you can go for a percentile, and here you can calculate correlation, but it is a rank correlation. Remember, here you cannot find out. You see, if you have an ordinal data and if you try to find out a usual correlation, which we generally say Karl Pearson correlations or product moment correlation, you'll get some number. Garbage in, garbage out. Statistics, good part is the best part is that you have enough softwares into it and you have enough data. Anything garbage in you give, you get a garbage out, and you get a beautiful diagrams and all kind of things. The purpose here is that here you can go for Spearman's rank correlations. Only rank correlations can be obtained, not any. You can go for a range kind of thing. And when it comes to the interval and ratio scale, certainly you can do almost all kind of an analysis, for all these things, be it a mean, be it a median, be it a mode, range, standard deviation, all kind of correlations, t-test, f-test, and all kind of things. So the message is simple, that depending upon the scale of the measurement of your variable, you should use the statistical tools and techniques. You have a list of statistical tools and techniques. We should be aware that under what circumstances, like as I have given an example, that if you have a binomial kind of things, nominal variable which is had got only two categories, absent and present, or you have a multi-state multinomial category, you should use these kind of mode, coefficient of contingency, chi-square, and all kind of. If you have a kind of an ordinal, you can, as I said, that there is an order, so you can have, you know, that median is a kind of suited for such kind of things, and you can go for So if you have ordered, means if you want to find out the correlations of that, whether this seedling figures had any role to play of any another ordinal variables, then you can go or kind of say incidence of disease, like how much infestations of there, if you know that low, medium and high infestations of this. So whether seedling figure has got any association with that kind of things, you can go for kind of rank of correlations. I'm not talking of association of attributes, of course those things and all, because chi-square can always be used. And then when it comes to the interval and ratio scale, as I said, that anything and everything can be used. Of course, here I'm not making a distinction, but you must be aware about the parametric and non-parametric test. When I'm saying t-test, for each parametric test, there is a corresponding non-parametric test, isn't it? Reason being is that parametric test comes with a lot of assumptions. And one of the basic assumptions of the parametric test is that you know the distribution of the population. And most often we do not know. And just for our convenience, for a comfort, when we do not have enough computational facility, used to assume that population follows a normal distribution, but that's not the case. That's not the case most of the situations. So whenever you are not aware of a population distributions, you try to find out the kernel functions and all kind of things, and you go for a non-parametric test when you are not aware of. And that's why in most of the social science research, if you look at it, since we are not aware of the distribution of the population, we go for a non-parametric test. But in a biological science, most often you are aware of some of the variables, then of course you can go for a parametric test. So when it comes to the quantitative data analysis, because I'll be mostly concentrating on the quantitative data analysis, then to start with, we start with an univariate analysis. This means you have data on a single variable, be it a plant height, be it a yield and all kind of things. So you try to have a kind of, first thing is that you try to have a frequency distributions, you have all kind of analysis which you can do on an univariate data. And the first thing is that whenever you get the data, the way when I came for the lectures, I have been introduced. Similarly, when you get the data, try to describe the data. And that's why the first thing one should go is try to have a descriptive statistics of the data, irrespective of what kind of analysis you are going to do. As simple as a regression analysis, as complicated as a machine learning or artificial intelligence techniques. The purpose is, the first thing is, you see, you have carried out an experiment and you have collected the data. So you have collected the data from a living things. So you try to know the data and analyze the data in such a way that is still, again, it becomes alive. So for that, we try to have descriptive statistics, means nothing but a measures of central tendency and dispersion. Okay. And then you try to talk about the bivariate analysis when you have data on two variables. And when we try to talk about a data on two variables, you try to find out the correlations, regressions, and all kind of things. So we try to talk about the correlations, that change in one variable, how it affects the change in another variables, and all kind of things we are doing it. But you know, in plant science or plant breeding, most often you have data on several variables, isn't it? When you collect the data on germ plant, you have several variables on that. And then comes the role of multivariate analysis. And then you try to talk about the cluster analysis, exploratory data techniques, or you try to talk about the factor analysis, you try to talk about principal component analysis, and several other things. And when it comes to the statisticals, we generally have two things. One is hypothesis, and one is level of significance, like whether you see 1%, 5%, 10%, all kind of things. So when it comes to the descriptive statistics, cut it short, you have measures of central tendency, and you have mean, median, and mode. And the purpose of explaining here mean, median, mode is, no, I am very aware about it, that I have not come as a teacher. I have not even, I consider this as a training program. I simply consider it as a kind of an interactions, and just to have an interactions, I'm trying to say something what I know about it, so that we can interact on it. So, but if you look at the earlier slides, you would have seen clearly that yes, if the data is in nominal, we have to go for a mode. If data is in ordinal, we will have to go for median. So we must understand that under what circumstances, which type of central tendency. The mean, median, mode, all are measures of central tendency. The mean had again arithmetic mean, geometric mean, harmonic mean, but each one had got a specific purpose. So where to quote mean, where to quote median, where to quote mode, where to quote arithmetic mean. You need to know the purpose. Similarly, you have a measures of dispersion, because most often you know that there are data sets, they may be same in terms of a mean or in terms of a central tendency, but still, like that some of the players, when you are selecting the players in the cricket, they may be having the same scores, average scores. This means they have the same central measures of central tendency, but still we say that he is more reliable, he is more consistent. So this means the run scored by that particular player is more scattered in the kind of. So how dispersed is your data, that gives you role of a measures of dispersion. So when you are not able to what you can kind of say discriminate on the basis of the tendency, central tendency, or an average kind of things, then you go for next measures, that is a second order moments. If you know the variance, so variance is always a square of it, isn't it? So first order moments is central mean median mode, then you move for the second order moments, that is dispersion, and the simplest is that you try to find out the range, mean deviation, variance, or a square root of it is a standard error. A standard deviation, a standard error has got a different meanings. Probably you know that whenever we talk of a standard deviation of a statistics is in a standard error. So if you have a several means and then you are trying to find the means of the variance of or say a standard deviation of several means, then it becomes a standard error. And then comes the coefficient of variations, when you are trying to explain a standard deviation as a percentage of the mean. So when you have your variables of a different units, generally you try to talk in terms of a coefficient of variation, because it is independent of the unit of the measurements, and it is always useful for comparison for different. Then if you are happy with the first order moment, that is central tendency, fine. If no, you are not able to discriminate, then you go for a second order moments, that is variance. If you are not able to discriminate the data on these two bases, then you try to introduce the data, the third order moments, that is skewness, whether your data is symmetric, asymmetric, and in asymmetric it is a positively skewed or negatively skewed, because only in case of symmetric distribution mean is equal to median equal to mode, but in positively skewed mean is greater than median is greater than mode, or in negatively skewed. So whenever you get the data, you just try to have a frequency distributions, you try to have a histogram, and that will tell you that whether your data is symmetric or positively skewed or negatively skewed. And if you are not satisfied with the third order moments, then you try to have a fourth order moment, that is known as a kurtosis, and there is a mesokurtic, leptokurtic, platykurtic. So if you look at these kind of things, and this is what create a lot of difference. You may be feeling that they are, because in isolation when you are plotting, that normal distributions also looks like a this, but normal distribution is mesokurtic. Okay, so you have mesokurtic, you have leptokurtic, you have platykurtic. But normal distribution and T distribution, as a statistician, I'm telling you that they are different. Though they have like a standard normal distribution, a standard T distribution, they have zero mean, but one has got a more area under the tail, and that is more risky into it. So for a given data set, if you have calculated the first order moment, second order moment, third order moment, and fourth order moment, this means you know anything and everything about the data. So the first thing is that the moment you try to analyze any data, try to get the descriptives of the data. And if you use any software, let it be R, be it SAS or anything, always there is a kind of a descriptive statistic. The moment you talk of a descriptive statistic, they will give you mean, median, mode, average, minimum, maximum, range, all kind of things. So and there itself you try to calculate mean, median, variance, skewness, and kurtosis. And if you know all these things of any data sets, you know anything and everything over there. There is no fifth moment kind of thing which is useful. Statistically, we say nth moments, but practically first four moments are, and that's the reason that even second thing which you want to see, that when you go for any graphical kind of things, you see the qualitative traits of your germplasm expressions, they are heterogeneous in nature, and that is the reason that we go for normalization of the data. Of course, we should be clear about that normalization and standardization is a different thing. Normalization, you try to normalize either between 0 to 1 or -1 to 1 and all kind of things. Standardization means you deviate from the mean and divided by the standard deviation. So So since your that quantitative traits, they are heterogeneous in natures, and since some of the traits in suppose yield per plant is in a kg and number of this seed per pod and all kind of, so they are very heterogeneous in nature. So in order to compare it, even you go for a regression or a clustering or any such kind of thing, we try to normalize the data, and or you want to normalize the data, then only you go for principal component, all kind of this types of data. Just for your information, whenever we deal with the data, it is more applicable to the social science people rather than the biological science people. There are basically three types. Here I have said four types of data. One is time series data. When you take data over time, that is a time series, price data, GDP data, all these kind of, they are time series data because you are taking data over time. Of course, remember when we say time series data, we only talk of discrete time series data, not the ECG data. DCG data is also a time series data, but that is a continuous time series. We are not dealing with that. That is completely a stochastic, completely different procedure. So time series data, where you are taking data over time. It can be a regular interval, it can be irregular interval, all kind of, it may be daily data, it may be weekly data. Of course, nowadays hourly data, census data are kind of each seconds data, and cross-sectional data means data taken at a particular point of time. Suppose you just try to know all the population is a kind of NSSO data. They are all cross-sectional data. Suppose if I just want to know what is the weight of all the candidates, this is a cross-sectional data. But if I am following you over years, that is a time series data. So all price data, all production data, they are time series data. And pool data, generally when you pull the time series as well as cross section. So suppose if you have say 5 state data, so if I know what are the important what is the food grain production of important states of India in 2022-23, that is a cross sectional data. And if each state will have time series data of production over last 10 years, so if I merge 10 states for 20 years, that becomes a full data. And when the same kind of cross section, same kind of estate, same villages is being surveyed, then that becomes a panel data. So far so good. We have understood the descriptive statistics. Now coming to the correlations and regulations, everybody knows that to study the relationship between two or more variables is known as correlation and regression analysis. Any kind of a relationship, and you know that this is kind of a negative correlations, this is kind of a positive correlations, and all kind of things. I'm just rushing it, coming to on the multivariate. So when it comes to the types of correlation, we have a simple correlation. When we try to talk about the correlation between only two variables, remember correlations is only the degree of linear relationship. So that's why if correlation is low, does not mean that they do not have a relationship. It only indicates the absence of linear relationship. They may be quadratic relationship, and then still correlation will be zero. Multiple correlations, you know, correlation between one variable and a group of other variables is a multiple correlation. And partial correlation, when you try to have a relationship between any two variables after eliminating the linear effect of the third one. So you know very clearly, suppose for a I am explaining a data sets which had a kind of 518 lentil expressions. We have 10 numerical characters. We are generally dealing with the numerical characters, and days to 50% flowering, plant height, days to maturity, 100 seed weight, biological yield per plant, primary branch per plant, and all kind of things. So these are the descriptive statistics. We have got mean, we have got minimum, you have got maximum, we have got CV. And if you look at it, that CV and all, so this through CV, you can very well know that, okay, there is a diversity on that particular traits or not. If there is no diversity, if you look at the days and maturity, CV is very low. So you know that you cannot get much diversity into it. Maybe that most of the exceptions, because of temperature and all, they reduce it to their maturity. They are forced to be, but there are certain traits like pods per plant. There are much more of the variations are there. So CV gives you a kind of a crude measure of variability in the data. Oh.
What happened, sir?
Whether I have lost the connection or not?
No, no, sir. You are there, sir. Sir, you share your slide, sir. Yes, sir. Slides are
Okay,
visible.
okay. Sorry. So then I have given an example of that, how you find out the correlation, as simple as that. And on the basis of the positive and negative correlations, usual and obvious interpretations you are making it fine. So not much questions on it. Then we go for a regression. And when we talk of a regression, it is a statistical tool. You try to investigate the relations between any two variables of interest. So y is a function of x, and it's a linear, and it can be so is this a function. It plays an important role. You can have a linear function, you can have a non-linear function, and that's what you say linear regression and non-linear regression. And linear and non-linear, you know, I will not explain this kind of things, but here linearity and non-linearity refers to the parameters. So those kind of things. So if you look at the regression analysis, what happens? You have a set of explanatory variables, or we say independent variables, and you have a kind of an dependent variables, and of course intercept terms is known as a bias. You try to sum over it, use some kind of an activation function, and I have deliberately used this diagram just to explain that how machine learning or a kind of neural networks, in neural networks and all kind of things, what happens, this activation function is a different, that's all. Here you have a linear activation function, and so what happens is that you have y is a function of x, so beta 0, it's a kind of intercept, beta 1 x1, beta 2 x2, and these are the partial regression coefficients. So y becomes, and how do you identify that adequacy of the model, which regression model has performed well? So you try to find out the coefficient of determination. So what is this? This is nothing but explained sum of a square divided by total sum of a square. So how much variability in that data you have been able to explain with this particular models which you have developed. So and with so as you know, and in my residual sum of square by total sum of square, so minimum is that you are not able to explain anything. So explain sum of square is 0, then it is a 0, and if you, it's possible that you are completely able to explain, so explain sum of square is equal to total sum of square, so r square is between 0 and 1. So this is the range of it, and why I am explaining is that you see that depending upon with this data set you can have, so there is nothing like a good r square or a bad r square. Only is that with that data set, what is the maximum r square you can achieve out of it. That's all. Now coming to the clustering part, as I said, the clustering, you all know clustering, but I am trying to explain clustering here because I am trying to introduce the fuzzy clustering. So clustering is simply you are trying to assign the data objects or any records or kind of any objects into different groups. That's known as a cluster. So any when you make a clusters, means all the objects or all the data in that particular clusters are homogeneous in that. So you can have two type of clustering. One, you can go for a hard clustering, crisp clustering. Either you are in this group or that group, or one is in a fuzzy clustering, like mostly you are in this group, but partially you are in that group also. So hard clustering, as I said, you are each observations is or each feature vector is defined exactly in one cluster. And when we talk about hierarchical clustering or non-hierarchical clustering, so here in hierarchical clustering, you know, agglomeratives, this means you have a simple, all observations are a clusters, and then the closest two are being as a single cluster, then this two is being single cluster, and this how you are moving it, and you can stop wherever you think that okay, you have got an appropriate number of clusters. And one is divisive one, like you start that whole population is a particular cluster, sample is a cluster, and then similarly you start dividing it into kind, and you can stop wherever you are. So this is the kind of estimate. When you talk of a kind of a k-means clustering, means you are identifying that you are sure that okay, there should be a 4 clusters or 5 clusters, and accordingly you are trying to have a kind of thing. Of course, when I'm saying of a dimension 1 and dimension 2, they are principal component dimension. Everyone is using the principal component, as simple as that. You see what is principal component, you know very well. Suppose there are 10 variables, you can make maximum 10 principal component, but principal component nothing but a linear combination of the original variables. So if you have weather variables x1, x2, x10, then when you are making a principal component, they are, each principal component will be a linear combination of all the weather variables, all the variables which you have, and they are formed in such a way that your first principal component accounts for as much possible as the variation as possible, and then the second principal component, and they first principal component and second principal component are orthogonal or independent of each other. So even if there is a collinearity, this means two variables are related, principal components will be unrelated, independent. So this means you can solve the problems of a multicollinearity, because when you collect the data, suppose on the germ plot, there are several variables which, suppose if you have collected the number of spikes and you have collected the kind of number of pods in that spikes, and then you have also collected that the total number of spikes. So sometimes it is related. So there is a problem of a multicollinearity in this case. So you go for a principal component. So principal component analysis has got two purposes. One is you reduce the data. You had a 10 variables, you can work with the 2 or 3 principal components. Second thing is that if some of the variables are related also, then you know that the basic assumptions of the regression analysis that each variables are explanatory variables are independent of each other. So that objective is being achieved through principal component. Now, when we talk of one, we have talked of clustering, that is crisp clustering. Now we are talking of a fuzzy clustering. Fuzzy clustering means these vectors, suppose this is one cluster, this is one cluster, but some of these variables, like suppose one of the accession in germplasm collection may be late in maturity and large seeded, as against positive trend in seed size and early, you know that. So some of this is mainly member of this cluster, but partially it is member of this clusters also. Such kind of clusterings where membership is defined that, okay, 80% this is a each variables of like 80% are of this cluster, but 20% in this cluster. Here in these situations, you can go for a fuzzy clustering. And what you are seeing the diagrams, what we did is we try to have a kind of, for any germplasm, we started with the 10 descriptors, and on the basis of the 10 descriptors, you will see that these are the fuzzy Siemens algorithms of fuzzy clustering. They are separate, but there are some overlapping into it. So this is not like a crisp clustering. If you look at the crisp clustering, you can see that their clusters are completely crisp in nature. They are not overlapping at all. But here, if you see that there is an overlapping. So in a real life situation, there is nothing like a crisp. So we should go for a fuzzy clustering. This is one exercise which we have done. Now, the second thing which I would like to introduce is that a non-linear principal component. What do you mean by non-linear principal component? Is that whenever you use the standard principal component, they assumes that the relationship among the variables are linear, and it is interpretation is sensible only where all variables are quantitative in nature or numerical level. But you know that suppose if your descriptors or germplasm are consisting of both numerical as well as categorical descriptors. Suppose if you want to develop a mini core or a clusters which includes both type of variables, quantitative as well qualitative concept. In this case, you can use for non-linear principal component. And how are you going to use this? Because here we use some kind of an optimal quantification. So what we do is, whatever binary descriptors are there, they are already category or like absent. They are already qualitative variables, absent, present, absent. Ordinal descriptors also they are in accordance. But whatever the numerical descriptors are there, we try to, in order to add, because we are going for a kind of an optimal quantification, what we are doing is we again categorize into several categories. Like suppose days to 50% flowering. So 58 to 62 is the first category, 63 to 67 is the second category, and any day, any germplasm having more than 93 days is in the 8th category. Similarly, plant height also we have done. So what we have done is that binary and ordinal were already categories in nature. Numerical descriptors also we divided into a kind of category in nature, a categorical variable, and then we are running. So now, if you look at it, of course, we have a simply component loadings kind of things, which you know in a usual principal components also. And of course, here we just want how these, which of the variables are like biological yield per plant or yield per plant or primary branches, they are important in distinguishing, while other accessions are not So depending upon that, how much variability, how much correlations they have, we can identify. So, but these important thing is that these loadings that are based on not only the quantitative variables, they are based on qualitative variables also. Here we have non-linear principal component, and then of course all these variables have been like principal component, we have been plotted on the dimension 1. The dimension 1 is nothing but the first principal component, dimension 2 is nothing but the second principal component, and we can see that which is obvious also, that all the numerical variables, be it a primary branch age per plant or yields per plant or pods per plant, they are highly correlated to each other, and that's why their all arrows are pointed in the same direction, and these all the all variables are highly correlated. You can very well understand that. And the length, this length of the arrows of the descriptors indicate their importance for distinction between the accessions. Suppose plant primary branches, if their length is less, this means they are less important in discriminating. If some of the things, so if you can see that some of the lengths are very less, so this is how you can use. But only thing I am trying to point out is here is that only novelty which I am trying to specify is that here we have used both. When I am saying both, this means we have used qualitative as well as quantitative characters, and then we have done this kind of analysis, and we try to say that the majority of the accessions forms ellipse kind of things. So this means only whatever is the genetic stock developed by crossing with the exotic material, we are found outlying as an outlying accession, and all are one or the same again on the principal component. And here we have same fuzzy clustering, but depending upon the principal component based on qualitative and quantitative variables. But you will see that not much distinction is there, because qualitative variables in this case has not contributed much into it. And finally, for all purpose, for developing a core or mini core, you can have a kind of crisp clusters. And when you have all these 4 clusters, then depending upon your priority, if you suppose your priority is you go for plant height, you go for more seed weight, then you know that seed weight for this particular category is highest, or these 2 categories. So you should focus only on the accession of these 2 categories rather than these 2 categories. They are always kind of, so suppose your idea is days to maturity, you want to go for an early maturity, then you know that these 2 groups are more important. Similarly, you can have a kind of yield characters, so you know that this category, this cluster is important for. So that's how we have done it. Now coming to the say machine learning. When I say machine learning, when let me have first this slide, and of course that will be easier. So let me talk about the artificial intelligence and machine learning together. So artificial intelligence or machine intelligence is what? Simply artificial intelligence is nothing like one technology or other technology. It's a kind of constellation of technology that enables machines to act with a higher level of intelligence and emulate the human capabilities of sensing, comprehending, and acting. So it can adapt to in a real life situation using cognitive process as the human mind. So you all know Google Home or Alexa kind of things which can interpret your natural language. That's why if you remember, like days are not far off when this Alexa and Googles will replace parents, in the sense that you see whenever like your kid is preparing a homework, they try to ask what is the capital of say India, or what is the capital of Andhra. So what happens is that we try to think about it. In the meantime, Alexa also run all kind of browse, and it gives you the answers. So they are what they are doing, simply interpreting the natural language. Whatever the questions have been said, they are doing some kind of a prediction and understand the questions, and they try to answer this. So this AI is everywhere, be it our phone, be it a car, banks, and that's why everybody is looking for racing to learn about AI. When we talk of an AI, this means you want computer to behave as a kind of an like a human being, and AI includes several things, maybe probability, maybe logical reasoning, and all kind of things. A part of AI is a machine learning, where you try to see that computers can figure out kind of a pattern in the data, isn't it? Pattern in the data without being explicitly programmed to do so. This means on the basis of the data, it is able to extract the pattern inherent in that particular data. And then a particular subset of machine learning is a deep learning. Deep learning is a subset of machine learning that enables computer to solve more complex problems. And why it is known as a deep? Because as simple as that, suppose if I say that, if you all know that, suppose nowadays so many online chess games are there, and you know that when initially computers started playing with the original players, it was a big deal. But now everybody knows that calculating a big calculations or having steps in the chess is hardly a kind of a choice of one into 1 lakhs, 1 into million, that kind of things. So if you program a machine for a calculations of division or multiplication or subtractions, and if you give all whatever difficult it is, if it is programmed for multiplication, any 20 digit into 20 digit number will be given. But if I ask you that how are you able to identify in a crowd to your relatives or your brother or sisters, or how you are able to identify the voice of your father among the so many voices, or how are you able to identify even the sound of your car of your father while the same car is there for him? So it is because of your intuitions. But if I tell you that give me the steps of this, it becomes too long, and that's why it is known as a deep learning. If I say you just to help a programmer to program it, that how you are able to identify, it is on the basis of a click of your intuitions. Immediately in a crowd, you are able to identify your near ones. But if I tell you that how it is, give a kind of a methodology, give a kind of a programs, then it becomes too deep. And that's what one of the reasons for deep learning. So when we try to talk about neural networks, it is one of the machine learning techniques. And neurals, of course, comes from central nervous system, neurons kind of things, you know better than me. So here the inspiration is from the biological models of the brains. And here again, neurons, as I said, works as a nodes. And as you know that neurons get information from several other neurons, and then it processes it and it forward it again, and sometimes it acts on it. But at a statistical perspective, we are interested in these neural networks because they can be used for a classification as well as for predictions. So simple, what happens is that you have, like in a regression analysis, you have an input layer. Here the terms are different, but same set of explanatory variables. You have an output layer, that is dependent variables. And only thing is that here this two is being divided by an hidden layer, a layer which one cannot see between the input layer, and that's why this layer is known as a hidden layer. And what we do is that, and since it is like nodes is from neural, so it is like a neural, and it is highly connected, that's why it is known as the networks. And since it is artificially created, so sometimes we say artificial neural networks. Objective is same, you want to map input and output, be it as simple as a regression analysis or be it a neural network. Objective is simply you want to map a set of input to a set of outputs in a, and here only in a neural network you can map, because if you see here kind of an activation function, you can map in a non-linear way. That's the only advantage of it. Needless to explain that regression and neural networks, one can have a comparison between these two, that here whatever you have data for estimation, that is known as the training sets, here that weight. So some of the terminology is different, and only thing is that like in a regression analysis you can go for a testing of hypothesis, and neural networks those kind of, because it's a data driven kind of things. So suppose if you want to go for a yield prediction, suppose same data set, if yield per plant you want to predict, and you have the data on day to flowering, plant heights, seed weights, and all primary branches or pods per plant, all kind of things. So they will serve as a input layer, and you want to get this output, and then naturally you can have one hidden layer, you can have two hidden layer, and these are all kind of an you have to decide. So first thing, you have to isolate the what are the explanatory variables you want to use, which dependent variable you want to predict, and then how many layers. Generally when it comes to the traditional neural networks, you go for a one layer, and in one layer you can have many numbers of depending upon the data, and these are the coefficients in regression analysis, but here we say weights, and these weights cannot be tested for a hypothesis like in regression analysis. That is the weakness of this, and that's why it is known as sometimes as a black box. So this how you can use a for yield prediction artificial neural network. Now similarly, when you talk of an AI, of course AI can be used for anything and everything. You would have heard of agriculture robots or kind of a drone. You could have heard of crops and soil monitoring. You could have some. So you can go for a prediction. You can go for an harvesting of the crops. You can go for all kind of crop health monitorings and all kind of things. But what I am interested is that for yield prediction. So if you look at it deep, as I said, usual neural networks means only one hidden layer. When this you have more than one hidden layer, that is what is known as deep. So deep can be anything. Deep can be more number of layers. Deep can be more number of nodes and all kind of things. So that's why the traditional neural networks are known as a shallow neural networks, and these neural networks are known as a deep neural networks. When we talk of an AI, we talk of one of the neural networks is known as the convolution neural networks. So wherever series you have a kind of a convolution. Convolutions is not, if you would have seen the any studio, you will see that the different images, how they give the brightness and all and make a different images. So they do the some kind of a linear operations, convolutions kind of operations with certain kernels, and so you have an input and you use some kind of kernels and you try to you give a different kind of a brightness. That's why like you would have seen many times that different type of images when you go for an studio, your passport size different images will be there, and then you are being given the brightest image or kind of thing. Then you go for a pooling and then flighten, and then you go for a prediction. So this is known as a convolution neural network. Similarly, you have a kind of long short-term memory, which is mostly used for a non-sequential data, sequential data, time series data. Here only is that this kind of you have the there is an information flow, but here they choose, you have different gates, and gate can choose that whether all information will flow through cell states, or we have to forget something, we have to add something. So different types of gates are being done in this, and that's why they are known as, and of course long-term dependency can be predicted. What we are trying again as a PhD students problems is that we, for any germplasm, you collect the data on plant height, you collect the different thermal information, you collect the different indices. So how those data can be used, this convolution neural networks, and whether we can predict pre-harvest grain yield or not. This is what we are trying for. So few things, whatever I have explained, we published for fuzzy clusterings and all, we published in this Indian Journal of Genetics and Plant Breeding. It was a kind of a long back as a MSc students, and we have started working on a deep neural network or AI, and we have published one for a price prediction. Now we are trying to do one thing. This is all from my side. Thank you very much, and thanks a lot for your patience.
Thank you very much, sir, for such a wonderful lecture. Now, request all the participants for if you have any question, you can ask from sir.
If some of you can show your face, you can switch on your video, it will be really nice. Otherwise, it's like in a bland mind searching for a black cat in a dark room. I have already talked a lot about it. So, yes.
Please put on your video, please, all the participants.
I got one question from Dr. Sunil R from Kerala. Sir, can you give an example for local control? Fantastic. You see, local control is, or error control is, when you go from RBD, if you know the randomized block design, RCBD, we say randomized control block design, randomized complete block design, you do the blocking, isn't it? You do the blocking, and blocking is always a perpendicular to the fertility gradient. Suppose you have a particular piece of land, and in that land, suppose you have done two treatments, one is with fertilizer, one is without fertilizer. Fine. So this side of the plot always is more fertile than this side of them. So if you have only two treatments and all the treatments are coming this side, then that will be having an advantages, general advantage. So what we do, perpendicular to that, we do the blocking, so that each treatment either can be got this or that, both. So blocking itself is a local control. Or if you know the factorial experiment, what you know, when suppose if you have 3 levels of irrigation, 3 levels of seed depth, then higher order interactions generally you try to confound, and that confounding. So this means what happens is that some of the interactions you are confounding and main effect or a kind of a first order interaction, so that it can be estimated with a more precise. That is what is the meaning of local control. Yes, Dr. Sunil, am I clear?
Yes, sir. Thank you, sir.
Thank you. Thank you.
Any other, please, can ask questions, sir.
Or Dr. Tarak, how are you?
It was nice listening to you, sir.
Oh, thank you. Thank you.
Means at least AI and machine learning, first time I'm listening any lecture. Although I have heard a lot, but at least I got a little gist of it. Had it been a physical lecture, it would have been more in.
Yeah, I love to have a physical lectures basically, because it's, as I said, that when you are talking to a screen, it looks like a blind man searching for a black cat in a dark room. So I was doing the same thing for 1.5 hours, but since you have been assigned the job, you have to do it, isn't it? So I was doing it, and I would have loved that there should have been a separate lectures on AI and ML, because the speed with which I have covered, I'm sure even I have not heard much what I have talked. So I'm extremely sorry if you have not understood it, and if you have understood a bit of it, I'm really thankful to each one of you.
No, I got that message, sir, and I got it. And later on, when I get an opportunity, I will learn at least. At least it is not directly applicable to me, but anyway, learning is not a bad thing, sir.
Basically, Dr. Tarak, in fact, if you yesterday only I was talking to you, the era is now only divided into 2 parts. Either there will be a genome editing, or there will be a data science and AI. Even like you see, texture analyzer, they used to have a texture analyzer. They used to have a kind of say crafted human crafted variables. Now when you go for an AI, they do not ask you that kind of a representation learning. When you are doing, they themselves decide that which are the variable parameters I have to obtain it. So very soon, many of the fields, whatever you see, when you are using Facebook, you come to know that one of your friends is within 1 kilometer or 2 kilometer at the airport, and I could meet some of the person. So AI is going to use in one or the other way. Either you going for an yield prediction, you going for a quality parameters, or you go for any kind of prediction or classification, be it a seed classification. If you try to identify the healthy seeds and disease seeds, there also it is AI which is going to help you. So one has to understand this kind of things one or the other way.
Any other question? I think there are no questions. Then I will propose a vote of thanks. Sir, first of all, I, on my behalf and on behalf of organizer, I would like to thank you for accepting and delivering such a wonderful lecture on statistical method in PGR evaluation. Sir, you have explained basic statistic and different statistical method using suitable examples in a simplified manner for a better understanding of our diverse group of participants. Sir, you have also given an insight about the machine learning approach and artificial intelligence for PGR evaluation or crop yield estimation in agriculture. Thank you very much, sir.
Thank you very much, Dr. Subhas, and for giving me this opportunity. And I'm really, as I said in the beginning also, I'm indebted to the organizers, that they, including the director of the institute, Dr. G.P. Singh sir, and all the coordinators, that you all have given an opportunity, because it's always good to talk with the biological science people, know their issues. It would have been better if I would have fired few good questions questions are always good, so that I could have understood that where I can use, because you see, like nothing can statistics has got it's an applied science.
Yes,
It
sir.
has to be always worked with a kind of a domain expert. So like there is nothing like I am not a statistician, I am an agriculture statistician. So the problem should emanate from the biological science or horticulture science or any other science, and we are here to give you kind of solutions which we know that best solution available with us. So thank you very much, and you are to all the participants. Thanks a lot for keeping patience to listening to statistics for 1.5 hours or so. But if you have any questions, if you want to have a kind of any kind of an analysis or collaborations, any kind of things, you are always welcome, or you can always contact Indian Agriculture Statistics Research Institute, exclusively done for an statistics, where you can get all kind of experts from design of experiment, statistical genetics, or say computer science, bioinformatics. Everybody is there. Thank you very much.
Thank you very much, sir. Now,
Thanks a lot. I'll leave the meeting.
yes.
Dr. Suhas.
Okay, sir. Okay. Thank you very much, sir.
Okay. Okay, Dr. Tarak. Nice seeing you after a long gap. I'm happy to see you. How is everything going on?
Everything is fine, sir. Everything fine, sir, in Pune. We are at, so we remember you, sir, at least.
So again, you have Dr. KV Prasad is there, no? Like
Prasad, sir, again is the director now.
Okay.
And, nice to have, sir.
That's good, good, good. Okay, then see you.
Okay, sir. Okay, sir.
Okay, sir.
Right.
Okay, sir. Bye. Dear participant, we have another practical afternoon at 2:30. Please be joined before 2:30, because our speaker used to join before, and all of you joined later, then it feel awkward. So, okay, we'll meet at 2:20. Sir, let me introduce first about our participants, training participants. Actually, we have 84 participants from diverse group of from SAU, KVKs, about international organizations like ICARDA and ICR Institute, sir. We have and now I would like to introduce our speaker first. I feel privileged to introduce our speaker, Dr. Vijay Chandra Mishra, senior scientist, discipline of agriculture in bioinformatics from Indian Agriculture Statistical Research Institute. He did his PhD from IRI New Delhi in agriculture statistics. He has a vast experience of research, more than 18 years, and he is also a faculty, IRA faculty in agriculture bioinformatics. He has a field specialization in agriculture application of artificial intelligence in computational biology, genome assembly, genomic data warehouse, transcriptomics, systemic biology, genomic selection, and GWAS. He has published more than 800 research articles in national and international peer-reviewed journals, and he has overseas exposure in laboratory of University of Louisville, Kentucky, USA. He has developed course material for postgraduate, PhD, and ARS in bioinformatics. I'm sure our participant will enjoy the lecture, this practical lecture, and they will get how to know how their research work can be analyzed using our software. Now I request Sir, Mr. Sir, for present.
Okay,
share his
thank
slide
you.
and present his presentation.
Okay, thank you, Dr. Subhas. Am I audible now?
Yes, sir.
Okay, fine. So first of all, a very good afternoon to all of you, and sorry for the delay, some technical glitch we were facing. So finally it resolved, and then I could able to join this training. So first of all, I will share my slide first. And is it visible now?
Yes, visible. Presentation mode, please. Yes.
It's okay?
Yes, working.
Okay. So as you know, this very lecture is related to the application of R software for PGR management. So in this very lecture, first I will go through the basics of R. And what is the R first? Means what does it mean, R software? What is the how you can download, install R packages, R software, and then how you can use this R software for PGR management. So I'll be dealing with some basic statistical analysis using R, and that's what we have planned for this lecture. So I will go through the presentation mode and side by side R program, running R program also. I will request you all, as I run the R program, you can also try with in your own system. Okay, so let's start with the R. So as you know, R is basically a very powerful programming language, and it is generally used for the statistical analysis, and all type of department which are using the statistical analysis, they can use this R. And the beauty of R is that it is it is free, very handy, and open source. So you can download it, and you can use all the packages available in the R repository. So basically, this more than 40,000 packages are available in the R laboratory, which are free for different purposes, and you can use all those packages. We will also use some package for running this some basic statistical analysis, and and the another advantage of using R is it provides a very good graphical facilities. So you will see how beautiful graph you can generate with the help of this R, and R is easily extensible. So you can make your own package, and you can just and submit your package to our repository, and in this way R is expanding day by day. And we have also developed several packages in R, and likewise you can also do this. So this is the another beauty of using R. So in the I will be running the program side by side, and if you face any problem, you must stop me, and you may ask whether I should slow or fast anything if you face any problem. Okay, so this is the introduction about the R. So for using R, the first requirement is to download the latest R release, and you can get this download option. You can just search in the Google, you will find the download option in the Google option. You will be getting this download option, and you need to select any mirror, because our repositories has many mirrors. Okay, so any mirror you can select, and from there you can get this R release, and then download this. This is executable file, so easily you can download it, and you can execute it and just install it in your system. So it is very easy. Just click next, you just click, and it will be it will be installed in your system. And for getting any package, if you want to install, first of all, I would like to describe what is the meaning of the package. So package is basically a module of a program which is made for a particular process, for particular analysis. So for different type of analysis, we have different type of packages with us. Okay, so you can use those modules or packages, and you can install these packages from local zip files also. You can download and you can install it. Okay, so I will demonstrate how you can install any package in the R. Okay, and every command in the R starts with a sign. This is the greater than sign. So it will start with this sign. Okay. So if you want to run any program, you need to write this. So R commands enter a console, and then it is executed. And you can save also this R command with file menu, and you can execute the R commands by just pressing Ctrl+R, and you can also save the final script from the script editor. And you can, when you quit R, a warning message appears for saving workspace. If you want to save all the work which you have done, you can save it, or if you don't want, you cannot save it. So all these facilities are available in the R. So, and then we have very good documentation in the form of help, and it is very easy to get help of any function if you want, or any package if you want to learn how you can use any package by just typing this. Like if you want to know what is the regression function, so just this is the question sign, so you can just type it and you will be getting the regression, all the help related to the regression. So or if you want to know what is the mean function, you will be getting all the details available by just running this command. So, and you can also save R command with the file menu, execute and quit. So this is the window of the R. When you install R, you'll be getting this type of window when you open it. So anyone tried to install R? So I may open R, okay, for you. So is it visible to all of you?
No, sir.
No, sir.
Okay. Let me. So it is somewhat difficult to do the practical online, and just trying to. So is it visible now?
Yes, sir.
Yes,
Okay,
sir.
so this is basically R Studio, and here we can write the program here, and here by writing any program we can run this program in the R. So if you install the R and if you open this, you can run side by side. When I'm running any program, you can also run this R. So here you will be having lot many menu, like file menu. So here you can create a new file, you can create, then open any file which is already available, then save option. All these options you can have here, which is common options for any software. And then in edit options, several options are available, like cut, copy, paste, and all these options. So basic window which we are having here means here you can write any program, okay, any code in R, and then just run. So like I'm running this principal. This is principal is a variable, and here we are providing a value to this variable. And what is this value? This value is 1000. So here we are providing. So for running this particular command, you just click here and just run. So it has been executed. So when you type here, like principal here in the bottom, okay. So whatever command you are running on the top is appearing here when it is run. Okay. So when you type here principal, like principal. So principal is coming 1000, means it has already been executed. So likewise, when you run the second command, like interest, okay, interest. So it is running. So interest is running. So when you type this, or you just simply select it and then run it. So it is coming, means interest has been run, and it is coming 0.11. So and likewise here you can also run this very command. So here also it is coming, it has already been done. So when you run this, so interest you can calculate like principal into rate and plus this into this. So writing any formula is very simple. By just multiplying all this, you will be getting. So when you see here, like interest, fine. So sorry, it has already been written. So just you can run this, and it is appear here. So result is appear here, means 550 is the interest. Okay. So this is one, means for any variable you can assign any value to a variable, and you can define many variables, and you can use all those variables in a formula, and you can create a variable with that formula, and you will be getting the result. So this is very simple. Likewise, you can also make the sequences with sequence function. So when I'm running this particular sequence function, so you just see it has already been run. And when you type here, this is the output, J is the output. So when you run this J, so it is coming. Means you have just assigned this sequence function, and it is coming. Likewise, you can also use another function, that is the rep function. Rep is for replication. So it will be repeating the value which you have provided, like 1 if you provided, and it will be repeating for 5 times. So when you run this sequence function, you just run this. So you'll be getting, when you run this R, so you just see 1 is repeated 5 times. So you can use any function, and you just save the result in a particular variable, and you can call that variable. Like we have run this ref function, and then we assign the result to this particular variable, that is the R. And then when you type R, you'll be getting the result. So likewise, we have the another function that is called C function. We will see what is this function. So here the C function, and here we are providing 3 variables to this. So when you run this, and when you run this str_vec, okay, so you just see first, second, third. It is containing three particular variables. Fine. If you want to know what is this sequence function, for any function, if you want to know what is the description, means how it can be used, and what is the details about any function, you simply run with this help function, and you'll be getting all the information available with this. So when you run this, like I'm running this, okay, so you just see here you are getting the details of this function. Sequence, so default is 3 method, and sequence what it is doing 1 2. So this is providing the range, and this is the increment which you want to do. So all this information you will be getting here about this function, and what are the arguments can be used in this function are here, and this is the details about this particular function. So all these documents have labeled here with example. So learning R is very easy with the help of help function. Okay, so you just use help function, and you'll be getting the all details about any function or any package if you want. Okay, so this is a very important function, and I suggest you you should use this function as maximum as possible. Okay, so it will provide you complete guide about all this function. So like if you want what is this C function, so here you just type this help under bracket C function, okay, and you just run this. So you just combine the values into a list. So all this information you'll be getting here. All details you'll be getting here. Okay. So all these things you'll be having here. So these are the basic command. You can also use, means if you want to generate a series sequence of the function series. So you can use this colon. So 1 2 3 all the numbers, and 2 to 1 all the numbers will be generating here with the vector form. So when you run this, and you just type this A, okay, here, and you will be getting, you just see, so 1 2 3 and 2 2 1. So all this sequence you can generate with the help of this colon. Okay, it's very simple. Likewise, you can also generate a matrix in the R, and generating a matrix is also very simple. So for this, we are using a function called matrix. So suppose we are generating this matrix with these values, okay? And here, what is the size of the matrix? As you know, there is in any matrix, there are some rows and some columns are. So here the number of rows, we are defining 3, and the number of columns 2, and accordingly we have these values. So when you run this, you'll be having the matrix. So you just type here A, just so you just see, you'll be getting the matrix. Please mute yourself. So likewise here also, you can, if you want to combine two particular vector, you can also use the R bind. So R bind means the column wise, the row wise, they are binding the values. So when you run this R bind, so you just see. So here two vector, 1, 1 and 1 minus 1, it is combined here. So you can make all these operations here according to your convenient. Likewise here, you can generate the another matrix, that is the B matrix we are generating, and it is generated here. So if you want to see what is this B, so you can also see this. So this is the another matrix. And if you want to multiply these two matrices, you can easily multiply this with this command. So you just see. So you can see the value of this. What is this C matrix? After multiplication, you will be getting this matrix. So generating a matrix, multiplication, all these things you can do very easily in R. Then we have a function, very important function, that is called factor function. So basically we have different type of variables in R, and one type of variable is called factor. Factor means we have categorical variable with us. So many times, like if you run any experiment, you'll be having different treatment, and the treatment can be considered as factors. Okay, so you can generate all those treatment with the help of this factor, and here we have generated a variable that is called X variable, and we can make this X variable into a factor. So when you run this X factor, you just see this is providing a factor, and here it is providing the labels of all these treatments. So like we have, if you have 3 treatments, 1, 2, 3 with 3 replications, so here you just see all the labels you are having. So these are the labels for all the 3, 1, 2, 3. So all this information you'll be, if you want to know the summary of this particular factor, so you just run this and it is providing the summary. So 1, 2, 3, and how many times it is replicating means 1 is replicating 3 times, 2 is replicating 3 times, and 3 is replicating 3 times. So all this information you will be getting with this. So then we have, we can also make the list of variables, means you have friend, then different names and child ages and all this information you can make in a list. So list is a function. So here we can provide the name and the number of children, child ages, all these things you can make by yourself. And when you run this, you'll be getting the list and how it is. When you just run this, you just see this is the name. Fred is coming, wife Mary, no number of children is 3, and child ages are 4, 7, 9. So you can make the list. Likewise, if you want to run this roll number and all, city's name and all, you can run this. You'll be getting all the details. So these are the basic operation you can use here by replication function, by this factor function. And then we have the another very important function that is called data frame. And so data frame, you can, like when you run this roll number and this, and you can generate the data frame. Data frame is similar to the matrix, but it looks like different. Just running this and you will see so you just see, these are the roll number and the centers available with this roll number. So this is the data frame. So data frame is very much used in R. And many times you need to create this data frame, and you can use this data frame in several analysis. Okay, so my speed is okay, or should I speed up or slow?
It's okay, sir.
Myself? It's okay.
Yes, sir.
Okay, so now we come to the a very important analysis, basic analysis we are dealing with. So I'm just unsharing this R and coming to my slide. Okay. So you can now we have the very important analysis. All the things we have already discussed this. So this is the correlation. Correlation, as you know, it is widely used in statistical analysis. Here we have the two variables and we want to know what is the linear relation between two variables. And so we can also do this in R by just creating the two variables. This is one variable we have created with the help of C function. And this is the another variable we have created with the help of, again, the C function. And we want to know what is the correlation between these two. And here we are using a function called COR. So COR is very simple. COR represents the correlation. So COR you just use, and then you can also use several methods. As you know, there are several methods available for the correlation, like Pearson, like a Spearman. So in method, you need to define this, whether it is Pearson or Spearman or what. Or you can make also the correlation test. So whether this correlation is significant or not, all these things you can make with the help of this COR function and COR.test function. So we will see, we will run the program and we will see how we can run this. So this is one variable we have created. And this is the another variable we have created, A and B. Okay. And we just want to know what is the correlation between these. So we are using the function COR function. So COR correlation between A and B. So we just run this. So this is the value we are getting, correlation values. Okay. So by default, when you run any correlation programs, by default, you'll be getting the Pearson correlation value, Pearson correlation. And when you want to run the another correlation coefficient, that is called a Spearman method. And as you know, a Spearman method is used where we have the data in the rank. Okay. So if you have the data, rank wise data, if you have, you should use Spearman. And if you have the simple values, so you can use the Pearson method. So correlation you can run, and this is the Pearson, and then you can run this Spearman. So you'll be getting this. So just see the difference between these two methods. Okay, Spearman and Pearson. So Pearson method, you're getting the negative correlation, but here Spearman, you're getting the positive correlation with different value. Okay, so these methods are very, very important. Whenever you use any statistical measures, you need to understand the measures first. Okay, so in what condition you should use what. So accordingly, the value will be different. Okay, so generally we avoid using this. We think that okay, Pearson and Spearman are the same, but it is not. Pearson is used when you have the general data when you have with you. When you have the rank data with you, you should use a Spearman. So this is the difference, and accordingly you will be getting the different value and the different meaning of these values. Here you are getting the negative correlation, but here you are getting the positive correlation. So these are important. And then you can make also whether these correlation values are significant or not. So how you can make it? By just testing them. So we use a t-test for getting the significance of any correlation value, and it is required because when you go on increasing the size of the sample, so what happens that a very less correlation value is going to be significant. And when you have the less number of samples, so very high value is not significant. So these samples, number of samples matters a lot. So here we are testing this correlation with core.test, and when you run this, you just see what you are getting. Here you are getting the t value, degree of freedom, and the p value. And what is the meaning of all this? You must understand. So t value means you are just applying t-test on this, and this is the t value, calculated t value, and this is the degree of freedom associated with this. So it is always n-1. So n-2 actually. So degree of freedom is in here. We are having the 9 values. So accordingly, the degree of freedom is coming 7. And this is very important. This is the p value. So on the basis of p value only, you can identify whether this correlation value is significant or not. So here the p value is coming 9497. That means this correlation value is not significant. Okay, and here also you can see the value of this correlation is very, very less. It is just coming 0.06, which is insignificant. Okay, so here we need to see whether it is significant or not. So on the basis of p value. So how you can test it? So as you know, there are level of significance attached with any p value. Okay, so when you apply, you need to first fix the level of significance, whether you want to test it on the 5% level of significance, 1% level of significance. All these things you need to fix in advance. So suppose if you want to test it at 5% level of significance, what does it mean? Means if this p value is less than 0.05, then you can say that, okay, it is significant. And when it is greater than 0.05, it means that it is not significant. So when you see this value 9497.9497, obviously it is significant, not significant, because it is far, far greater than the 0.05, means 5% level of significance. It is not significant. Okay, and it is also providing the confidence interval. You just see 95% confidence interval. So if this value falls between these interval, you can say that, okay, our test is significant. But if it is not falling in these intervals, you can simply say that, okay, these values are not significant. Okay, so here you are getting the correlation value this much, and this is obviously not falling in these intervals. So you can say that, okay, our test is not significant. So this is very, very important. This is very basic things, but you must understand, and you should take care of whenever you are using such type of analysis. Okay, so this was about the correlation. So accordingly, we have the another important measures, and that is called regression. So here we have two variables, and one variable is dependent variable, another is called independent variable. So this is simple linear regression. When you talk about, this is the formula of or model of the simple linear regression. Okay, and then what we do, we fit it, and we want to know when you have the value of x with you, and when you have the value of beta 1 and beta 0, that is the unknown parameter. So you can just estimate it, and by using this minimizing the square distance. So when you minimize it, and then you will find the value of beta 0 and beta 1. And when you put it, you can get the prediction of a y value, that is the dependent variable. Okay. So all these things you can do with the help of R. So this is the simple regression. Complicated regression also you can do. I am just demonstrating a very simple regression, very simple model here. So for this, we are going to use a function called linear model, LM, linear model. LM represents the linear model. And here A and B, here A is the dependent variable and B is independent variable. So when you run this and you just store the result in the form of model, and you run the another function that is called summary function. Okay, summary function on this model, you will be getting the details of all this. What is the estimated value of alpha, and what is the estimated value of beta, and what is the test value of all this, means what is the t value, what is the p value, all these things you'll be getting here. So just see here the estimated value, what is the error associated with this estimated value, and how you can, what is the, when you apply the t test on this, so what is the value you are getting here, that is the t value. And then the last column is very, very important, and that is called p value. So you can easily find whether this intercept, which is we are estimating, whether it is significant or not. Accordingly, we have the b value, which we are getting the estimate of this, whether it is significant or not. And I just told you how you can make the inference about the significance level. Where it is less than 0.05, you can say that, okay, this value is significant. When it is greater than 0.05, 0.05 means 5% level of significance. So you can say that, okay, this value is not significant. So a very simple function, that is LM function you are using, and summary function you are using, and you're getting all these results within a second. So this is the power of R, using R. So I'm just demonstrating this particular regression. Okay. Okay, so So here we are using the function model LM function. Okay, LM function we are using on this A and B, and A is the dependent variable, B is the independent variable. So any regression you can use with this powerful function that is called LM function. So you just run this, okay, and then you run this summary. You just see we have got all these results. The estimated value, standard error, t value, p value, all this value. So any query or questions so far? I don't know whether we are interacting with each other or not. So if you have any queries, if you have any question in your mind, you may ask, because it is very important when you go with the practical class, it should be interactive. Okay. So anything, if you want to know, please ask. Otherwise, I will understand that it is understood to all.
Dear participant, if you have any questions, if you are not understand, you can just ask. Right
Anything related to anything, any minute thing, if you want to know what is this t value, p value, standard error, estimate, why we are using. I'm just making, I'm trying to make you understand, but when we are in the online mode, so it is really very difficult because I'm not getting eye contact to you, and I'm not understanding whether you are getting or not. Okay, so I just understood you have already understood all the things. Okay, so let's move further. Okay, so now we are going to use a very important another type of analysis, and that is creation of the box plot. And box plot, we are using many analysis. You'll be getting the very beautiful box plot graph. And what is this box plot graph? I'm just sharing the slide. So we have discussed about the correlation, basic statistics we have discussed about, then correlation, then regression. And now we are going to use a very important function that is called box plot. And where we are using this box plot actually, what is the need of using this box plot? First, we need to understand this. So basically what happens that when you have the data with you and you want to know the distribution of that data. And what is the meaning of distribution? Distribution means you want to know whether your distribution means data is evenly distributed or normally distributed, and what is the mean value, what is the range of how much variations present in the data. All these information you will be getting. What is the minimum value, what is the maximum value, what is the first quartile, second quartile, third quartile, all these things, all this information you will be getting. Whether your distribution is normal distribution or skewed distribution, because when you apply any test in statistics, it is advisable to use the data which is normally distributed, because there are assumptions with almost all parametric tests, whether you are using t-test, whether you are using z-test, whether you are using the another any type of test, if you are using f-test. So for all these tests, there are assumptions that the data should be normally distributed. And how you can get the idea whether it is normally distributed or not, whether it is skewed symmetrical distribution or it is skewed distribution, because for a skewed distribution, we need to do some different type of test. You cannot apply t-test for a skewed distribution. You cannot apply z-test for a skewed distribution. So for all these things, all these cases, we need to generate this box plot. Okay, fine. And if you don't have data with normal distribution, you need to transform this data into normal distribution. So all these things you need to do prior to apply any test or any analysis, any statistical analysis. You need to do all such type of transformation. So it is very much required when you have the data with you, whether it is symmetrical distributed or not. So all these things, all this idea you can get with the help of this box plot. And we can use this if you want to see how you can generate this box plot in R. So very simple. Here we are using a data called empty cars, and we are generating a PNG file. PNG file means a particular image file in format, that is PNG format. And we are generating this box plot with base variables. So here we have dependent variable MPG, and this is independent variable CYL. So data is this. So when you define, so here this is a graph. So on x-axis we have the number of cylinder, and the y-axis we have miles per gallon. And the main we are writing this mileage data. So all these things, all these commands, when you will run, you'll be getting the beautiful graph. And this is called box plot. And what is this? From this box plot, what you are getting, what inference you will be getting. This looks very simple, but it gives you a lot many things, lot many idea how your data is behaving, how your data is distributed. Okay, so when you see here we have a box, and this is a line, and this is the range of this. So basically this particular variable is the variation between this variable and this is the maximum value. Extreme values is the maximum, this is the minimum value present in the data. So, and this is the distribution. And in this box, this is very important line. Okay, if it is present in between of this box, you can say that your data is symmetrically distributed, or even you can say that normally distributed. But when it is deviated from the midpoint, it is skewed. It is called skewed. So when you see this particular variable, this is skewed because this is not present, this line is not present the midpoint. Okay, so it is a skewed distribution you are getting, and this much of variability or this much of variation you are having in your data. So but when you see this, this is somewhat more symmetrical in comparison to this variable. And here the variation is very, very less in comparison to this variable. You just see, this is the variation, range of the variation. So variation is very, very less in comparison to this. When you see this particular variable here, this is also somewhat symmetrical, more symmetrical in comparison to this. But when you see the variation present in this data, it is more than this and less than this variable. So all this information you'll be getting by just looking into a simple graph that is called box plot. And you can make it by very simple, some command using, you can use in R, and you will be getting a very beautiful, this box plot. So I'm just running this command. So this is the data which we are using, and I will tell you any data which is already present in the R packages. There are several data are present in the R packages. You can use those data, and you'll be getting the result. So we are here, we are using the data empty cars that is already present in the R, and you just run this. and you just run this particular box plot function. And you have here, you have the beautiful data, beautiful graph. You just see. So this is the power, this is the beauty of this R. Okay. So after offing it, so you will get off from the screen. And then we have another important analysis, and that analysis is called, you might be using this type of analysis. That is called ANOVA. First, we should understand what is the meaning of ANOVA and where we are using this ANOVA. The full form of the ANOVA is called analysis of variance. And what does it mean where we are using this ANOVA? Okay, first we need to understand this. So basically, when you are conducting any experiment, okay, any experiment, so you are applying different treatment. So you are getting the variation depending on the different treatment. So some variation is due to these treatments, but some variations are due to the experimental material which you are using. Okay, and that those variations are called experimental error. Okay, experimental error. So when you divide this complete variation which you are getting in your data into two parts, one part is due to the known factors. Known factors are what? Which you are applying in the form of different treatments. Okay, so these are known for. You know, these are the treatments you have applied, and due to that, these variations are coming. But some variations are due to experimental material and many other causes. Okay, and those are called experimental error. So the purpose of ANOVA is to dividing your variation present in the data into two different parts. One is the sources of variation which is known to you, and the another part is the sources of variation that is unknown to you, that you don't know. Okay, so this is very, very important because you must know what is the amount of experimental error present in your result. Okay, so that you can easily identify what are the treatments, significant treatments, whether your treatment are significant or not. Suppose you have two treatments. You have applied one treatment and you have applied second treatment, and you are getting the variation in the result by applying these two treatments. But you don't know whether these variations are coming due to the changing of the treatment or due to the experimental material. So, and if you know what is the amount of the experimental error present in your result, okay? So all these things you will get the idea with the help of this analysis that is called ANOVA. This is very important analysis we are using this ANOVA. So, and ANOVA is basically used for testing the different means, different treatment means. So basically by using ANOVA, you're testing the different treatment means. Okay, so for one treatment, second treatment, third treatment, fourth treatment, and what is the difference between these treatments, and what are the treatments which are coming to the significant. Okay, so suppose when you are conducting any experiment, you have new germplasm with you, and okay, and you have the chick with you, and you want to know what are the new germplasm which are significant different from the checks. So for all such type of analysis, you are using this ANOVA. So I think you must understand what is this ANOVA and how you can use this ANOVA through R. This is very simple. So here we have a size. Here we are generating a size variable. Fine. So size variable is like this. And here we have the population, or you can say the treatment. Okay, like A, B, B, C, C. 3 treatment you can consider. Okay, so size is the dependent variable and population is the independent variable. Okay. So here, how many population we are having? 3 population with 4 replication, you can say, or 3 treatment with 4 replication, you can say. Okay, and we want to know whether these are significant or not. These populations are significant or these treatments are significant or not. And how you can do this? By using this ANOVA. And for getting the result of ANOVA, the simple function is AOV. Very simple. And this is the dependent variable. This is independent variable. Fine. So you just run this AOV and you'll be getting, you can store this in any name you can provide. Here we have provided AOV.model. Any name you can provide. This all depends on you. So, and then you see, just use the another function that is important function summary, which we have used earlier in the case of regression and correlation. So summary you can use and you'll be getting this result. Okay, so here what we are having here, first you must understand. So here we have the source of variation. So what is the source of variation? The first source is, as I already told you, the treatment which you are applying. Okay, and this is the treatment, means population are the treatment here. And the second source of variation is the residual or experimental error. So here we are having this. And the second column, when you see, this is called degree of freedom. So here, how many population we are having? 3 population. So degree of freedom will be 2. And how many data we are having with us? How many? So 4 replication which we are having. So total data point are 12. So 12 minus 2 minus 1. So this is the residuals, degree of freedom. Here we are having the sum of square associated with all this, then mean sum of square, F value associated with the treatment, and the P value. This is very, very important. And here you just see the description about this star. Here you see just 2 star is coming. Okay. And 3 star also may come, 1 star also may come. And what is the meaning of this? Okay. So when 1 star is coming, that means these treatments are significant at 1% level of significance. Fine. When 2 stars are coming, that means these treatments are significant at 0.1% level of significance. And when 3 star is coming, so less than that. So very precise. So all this information we are having here. So you just see, this is the value 0.00457. So obviously this is less than 0.01. Okay, 0.01. So 2 star is coming, and that means at 1% level of significance, these treatments are significant. Significant means they are different, significantly different. Okay, so all this information you will get with the help of this R. So I am just sharing. Okay. So here we are defining. Yes.
In chat box, some question.
Chat box. Okay.
How to create Excel file for analysis in R?
How to use Excel file? Okay.
How to create Excel file for analysis in R?
Create Excel file.
How to create Excel?
If you have Excel file, you can create Excel file. If you have the data in Excel file, you can use it.
Ask data format means.
Yes.
Sambirat Kumar.
Okay. So I'm just replying this. So suppose I got your question. I think you have the data in the Excel file and you just want to use this Excel file data in R. That's what you want to use it. So basically for this, there are two ways of reading these files in R. The one way is you can you can save it into CSV file. Okay, fine. CSV file, you can make it, and you can use a command that is called read.csv. Read.csv. And I'm just writing this command. If you want, you can write it. Okay.
Sir, another question from Dr. Sunil, sir.
Okay. One by one, I'll be replying. Okay.
Yes. Okay, sir.
So here we have the data like in the CSV format. So you can save any Excel file into CSV format. It's just like Excel file. And you can use this read.csv and you can provide the path to your file, or you can use another function called file.choose. So easily you can browse your file, Excel file into it, and you will be getting the your data into R. Okay. So this is very simple. Like when we have run this command, so it will open a window. You can see here, and you can just locate your file where it is present, and you can read it in R. So this is very simple. The another way of doing this is using a package called XLSX. So for using a package, so for this we need a command that is called install.packages. For any installation of any package, you can use this command that is called install.packages, and here you can use XLSX package. So this package will be installed in your system, fine, and then you can load this package. And how you can load this package, I'm just demonstrating. So it has already been installed. And then after installation, any package if you want to use in R, for that you need to load it. And how you can load it? By just calling a function called library. Okay. So when you run this library function, it is loaded. So you can use that read.xlsx. Okay. Here you can use the same like read.csv. You can use this read.data read.xlsx, and then again you can use file.choose, and you will be getting, when you run this here, Okay, this file.choose and is not working here. So here you need to provide the path to your file where it is present in your system. So when you provide the path, it will automatically read. So there are two ways of reading any Excel file in R. Whatever the method you need, it is convenient to you, you can use these methods. Okay. So this is one question. What is another question we are having?
Sir, how to get code for various analysis? For example, L into T analysis. Something is given, sir, by Dr. Sunil from Kerala Agriculture University.
Okay. Yeah, fine. It is very simple. Means all packages and all helps are available on the net. Okay. So it is very simple. If you want to this LNT analysis, you just write LNT and R packages for LNT analysis. So in the Google, you will be getting the R package associated with that. And for details of using all R package are also available in the package itself. When you install this package in the system, you can just type help and the name of the package. You'll be getting the details of all this. As I already discussed in earlier, that complete document related to any package or any functions are available in R. So, but you just type the name of the package. I am just typing this. What is this? XLSX package, which we have just installed. It will give you the complete documentation about this. So I'm just typing help and the name of the package XLSX. Okay. You just run this. You just see. Here you are getting the complete details of this. You just see what with example. So it is very easy to learn R. It is not a big deal. You can do all the analysis. You just type the packages for this particular analysis. You'll be getting the package. You just install it and get the help related to the complete documentation with example in R. Because R, any package, when you create any package, like we have created many packages. So we need to create the help of that. How you can use it and all this, then only it will be submitted in the R repository. So you'll be getting the complete documentation regarding any function or any package. Okay. So this is the beauty of R. So anything else?
Sir, another question by Dr. Nidhi Gowdy. How to set working directory in R?
Yes, this is good question. So this is very simple. There is a command called setwd. Setwd means setting of the working directory. Okay. So any path you just provide here, which you want, or folder name, if you provide here the complete path of that particular folder, that will be your working directory. So this is very simple. Setwd, the command. Any question? Okay, so if there is no more questions, so we can proceed further.
Yes, sir.
Okay.
No
So
questions.
we were talking about the ANOVA. that is the analysis of variance. So here we have two variables. We have defined this. This is one variable, size, and this is the another variable, that is the population. So population means the treatment we are providing, and this is the size. Okay, so when you run this function AOV, it will give you the ANOVA. And you just see, run this summary of this model, you just see. This is the ANOVA you are getting, along with whether it is significant, at what level of significance. Okay, so here you just see, as I already described this sources of variation. So there's a population, residuals, degree of freedom, sum of square, mean square, F value, P value, all this information you will be getting. So here, by looking into this, you can say that your treatment is significantly different from each other. So these things you can do. Now we are coming to a very important analysis, and that is called augmented RCBD. Because in many cases you have several data with you. So first we will see what is the meaning of this augmented RCBD. I'm just sharing the slide first. So basically what happens that you have many number of germ plasm with you, okay? And you want to know whether your new germ plasm is significantly different from the already existing chicks or variety, okay? So when you want to run this, this type of experiment, so basically what happens that it is not feasible to conduct this big experiment. Why? Because you have 200 germ plasm, and for when you use any RCBD, that is called randomized complete block design, when you are using this design, so it requires many replications. Okay, so suppose minimum 3 replication it requires. So if you have 200 germ plasm, okay, and you have 3 replications, so how many plots you need? In 600. And this is one example. You have many germ plasm. So for controlling the error, it is very difficult. And what is the meaning of the controlling the error? So generally, there are 3 principles associated with any design of experiment. When you're conducting any experiment, you must know what are the basic principles attached with any design of experiment. The first principle is called randomization. Randomization means random allocation of the treatment. Then only you can apply any test. Okay, so this is the first and foremost requirement for analyzing the data. Okay, so this is called first principle, that is called randomization. The second principle is called replication. And replication, we just repeat the treatment. Why we are repeating the treatment? For estimating the error. Without replication, you cannot estimate error. Are you getting my point? So for estimating the error, we need replications. So this is the second principle of design of experiment. The third principle is called local control. And what is the meaning of this local control? We are maintaining the homogeneity between within a block. Okay, when you are creating the block, we are maintaining the homogeneity. Okay, so when you have large number of treatments, for maintaining this homogeneity is quite difficult. For getting the replication, it's also very difficult. Okay, randomization you can do, but these 2 principles, it is very difficult to apply. One is the replication, another is the local control. So controlling, so local control, basically we are controlling the experimental error present in the experiment or experimental material in the form of maintaining the homogeneity. Okay, so for controlling this error, we are not very convenient to control this. So for all such cases, when you have large number of treatment with you, and most of the treatment you are just want to comparing with only few number of treatments like 1, 2, 3, or 4. So for all such cases, we are using this augmented RC. And here, what is the meaning of augmented RCBD? Means here we are not going to replicate all the treatment, all the germplasm which we are having, but just replicating all the checks with which we want to do comparison. Okay, so we are just replicating those checks only, and on the basis of those checks, we are getting the estimate of the error. Okay, so that's why it is called augmented RCBD. Augmented means we augment these checks with the main treatments. And here, how we are replicating this? How we are replicating this test, these checks by just making several blocks. Okay, so we are making just 5 or 7 blocks. So accordingly, the checks will be appeared in each block, and accordingly we have the replication and estimate of the error. So now I think it is clear what is augmented RCBD and where we are going to use this augmented RCBD. Okay, so we can use it by a package called augmented RCBD, and you will be very happy to know that this particular very important package is developed by NBPGR itself. So your host organization, which is hosting this training, has developed this package that is called augmented RCBD, and very good package. You can use this package. So by first you need to install this package. I just demonstrate you how you can install any package by using a command called install.packages, and in inverted comma you can write the name of the package, and then after installation you need to load this package into our system. Or using any package, first you need to load this. And how you can load this? By using a function called library. Okay, so library function we are using for loading this augmented RCBD. And then here we are generating the data. So here we are generating a block. Okay, so here we are generating how many blocks we are having? 3 blocks. Okay, and then we are generating a treatment. So these are the treatment we are generating, and then we are generating the response function. So here we are having the 2 type of response function, this y1 and y2. And then after generating all these variables, we need to convert or combine these variables together and need to convert all this data into a data frame. Okay, so that we can use it directly in any package. Okay, so for this you are just combining these variables and converting these variables into data frame by using a function called data frame data.frame. Okay, and here we have the data. So now we have the data, and how you can use this data. So this data will looks like this. Here you just see, here we have the block, here we have the 3 blocks, and here we have the treatment. Okay, so and then we have the response. Okay, so when you see, closely look into these treatments, you just see there are 4 treatments which are replicating in every block. You just see 1, 2, 3, 4. Here also, again in the second block also you are getting 1, 2, 3, 4. Then in the third block also you are getting 1, 2, 3, 4. So these treatments are going to be replicated in each block. As I told you, these checks are generally replicated and all other treatments are not going to be replicated in entire experiment. So this is called augmented RCBD. Okay, and here we have the two type of response. One is the Y1, another is the Y2. Fine. So when you run this, how you can run this? So for running this, first we need to convert this block and treatment into factor. So for converting this into factor, what we are doing, here we have the data and here we have a BLK, that is the block and block variable in the data. So this is represented by $. So here in the data itself, we are having many variable. One is the BLK, another is the TRT, that is the treatment. Then third one is the Y1 and the fourth one is the Y2. So when you want to retain any variable for further analysis, you need to assign it with the $sign, means data $BLK, data $TRT. So this particular variable basically you are using, and this variable present in this data. So here adds dot factor to convert this variable into a factor variable. Okay, again we are using, so treatment, for treatment also we are converting this treatment into a factor. Okay, so in this way we are converting, then only you can use it. So, and then we are using a function called augmented RCBD. Augmented RCBD is a function, and here we are using the block, then treatment, and this is the response. This is the Y1 data. And here the method we are using LSD, and level of significance we are using 0.05. So, and by default, all these other parameters you can keep it. And when you will run this, you'll be getting this. And what is the meaning of this? This is very important, because for running any analysis and getting the result is not a big deal. For getting the inference from the result is a big thing. So that you must understand. First, you should understand whether your data is able to do analysis, is suitable for analysis or not. So this is called exploratory analysis that we have done through box plot and all this. So you can get the idea. And then the second one, what type of analysis is needed. And the third one, when you have the result with you, what is the meaning of that result? So that is very important. Okay, so here details about the complete data and the results are here. So here you just see, here we have the number of blocks are 3, number of treatments are 12, number of check treatments are 4, number of test treatments are 8. And what are the check treatments? That is 1, 2, 3, and 4. So basic description about the data are available here. Then we have the ANOVA, that is the analysis of variance. For two type of ANOVA we are getting. First ANOVA with when you are adjusting the treatment effect. And the second ANOVA you are getting then, which indicates that you are adjusting the block effect. Okay, so here when you are adjusting the treatment, you are, this is the block, and here we are not going to do any adjustment in the block effect. So here we are ignoring the treatments. Okay, and for treatment we are eliminating blocks. Then these are the checks and test versus check, and this is the residual. So all sources of variations are present here. These are the sum of square, mean of sum of square, F value, and P value. So when you see here, when you adjust the treatment, you just see the block is significant here, because the value of the P value is, what is the value of the P value? Means 0.0298. It is less than 0.05. So at 5% level of significant, it is significant here. But the rest of the treatment and all this are not significant. Okay. So only blocks are significant. Means block which we have generated are significantly different from each other, but treatments are not. Okay. Because these values are greater than the value of this 0.05. Okay. So when you adjust the block, here just see treatment, you are ignoring the blocks for calculating the treatment sum of square, just ignoring the blocks. And here you are getting the P value. Here, none of the sources of variation, whether it is treatment or block, are significant. Okay. So here from this, you can get the idea. Then it is also giving the further analysis, means what are the treatments which are different from the checks. Okay. And so means value, standard error, minimum, maximum, and all this R square value, all these values you are getting. And this the adjusted means value also you are getting. Then you are getting the coefficient of variation also. And then overall adjusted mean, then a standard errors associated with each source of variation you are getting with confidence interval, 5% level of significance. So all this information you will be getting. Then what is the lower value of the confidence interval, higher value, and how it is comparing the treatments. So all this value will be getting. So however, in this case, these values are not required because none of the treatments are significant. Okay, treatments effects are not significant. But when treatment effects will be significant, you will be able to understand what is the meaning of this, because the further analysis to test what are the treatments which are significantly different from the checks. So this further analysis is required when you have the treatment effects are significant. Okay. Then we can also use for multi-trait also. Here in the first case, we have used this for a single trait. For multi-trait also, you can use this. And for this, you are using another function called augmented RCBD.bulk. Okay, so here the same type of parameters we are just providing to this function, data equal to data, block, BLK, treatment, TRT, traits. Here we are having, just see, in the earlier case where we were having only single trait, but here we are having 2 traits, then checks, then level of significance, and then all this information is for getting the graph. So what type of graph you are getting? So all this information you can provide here in the function itself. So you're getting the result like this. Now we are using the same data. So ANOVA for Y1, ANOVA for Y2. So these are the details about the data which we are having with us. The same number of blocks are 3, number of treatments are 12, number of check treatments 4, number of test treatment 8, check treatments. All this information you are having. Here you just see. This is the ANOVA after treatment adjusted. So just see, here blocks are significant for the first variable of response, and here also you are having the block significant. But here treatments are also significant for the second response. And the test versus check are also significant. So this is the difference between these two responses you are getting. So you can compare also. So for which response you are getting what. Okay. So this is the another ANOVA when you are adjusting the block. And here also the similar type of results you are getting. Okay. And again, you are getting the coefficient of variation and overall adjusted mean, all type of information you are getting. Then you are getting the PV value, GV value, EV value, GCV, and PCV. So all this information you will be getting. So now we can run this whole. So here we have we are installing this package and then loading this. I've already installed this package in our system. In your system, you can install this package and load this package. Then we are generating this block variable, then response variable, and then another response variable. And then we are making the data frame and then converting the all variable into factor. And then we are running this augmented RCBD and we are getting the result. Okay. And then similarly, we are running this multi-trait augmented RCBD and then getting the result. So all these result you will be getting out of this very beautiful package called augmented RCBD. Then we have the another type of analysis, and that is called cluster analysis. So cluster analysis you will be using when you have when you want to know the diversity present in your data, or you want to make the grouping of your germplasm. If you have different type of germplasm, what are the germplasm falls under one group, and what are the different germplasm? What is the distance between these germplasm? All these things you can get with the help of clustering. So basically, through cluster analysis, you are making the group of homogeneous type of germplasm or treatment, you can say, and then you can get a dendrograph type of things, and you'll be getting the very good, beautiful graph. So for using this, for doing this analysis, we need to install a package called cluster. Okay. So, and then we are installing another package called Facto Extra. And then we are loading this package library cluster. And then we are getting the idea what is there in the iris package. And then, so straight away, I'm going to run this. So you'll be getting the graph like this, dendrogram you'll be getting. So I'm just running the code. But you just see it is installing this cluster package. Then it is installing the another package that is called Facto Extra. And then we are just loading this library, and then we see loading the iris data. And then we see what is iris data. So here we have several like sepal length, sepal width, petal length, petal width, and these are the species. Okay. So this type of data we are having, and then we want to make the group of these. So this is the data we are having with us. And then for this, we set a seed, and then first we run the k-means clustering. I think there's some problem, I think. First, we should run the another one. It is just give me. So basically, we are using iris data, and for creating this cluster means dendrogram, we need to first we need to calculate the distance matrix, and for calculating the distance matrix, we are using a function called dist function. Okay, dist function, and method we are using. There are several method for calculating the distance matrix, and the most popular one is the Euclidean. So here we are using the Euclidean distance method, Euclidean distance method, and then so then we use the H cluster, that is the hierarchical clustering function for on this distance matrix, and there are several method actually available for calculating or making this dendrogram. One is the average method, that is called UP method, that is, and then linkage method, complete linkage, single linkage. There are several methods which you can use here. So here we are word method. So here we are using the average method, and it is widely used method. So when you run this, And then you need to do you can make the dendrogram with the arrays. You just see, you will be having the dendrogram by using this plot function. So we have just run this plot function on the result of this res SC. So you'll be getting the plot. So through looking into the plot, you will be getting the idea what are the germplasm, what are the variables which falls into a cluster. So all this information will be getting with the help of this cluster analysis. So that is all for today, I planned. So if you have any query, now you may ask anything related to any which we have discussed today.
The participant, you have any question, you can ask. And thank you very much, sir.
In chat box, questions are there. Can multi-environment data analyzed in augmented RCBD? One question.
Multi-environment data. Okay. So of course you can do this by that is not for that we need something in the model we need to change, because in the model we need to change. We need to incorporate the different environment into the data, and for RCBD means this package is not going to work there. So there are several there's some other package you can use for this purpose, but there is need to do some changes in the model because it is not taking that environment variable into the model, so you cannot use it. Then we have if we wish to go for correlation or PC analysis based on adjusted mean. Okay, actually what happens that correlation you can use when you don't have any adjusted means, and PCA, actually PCA is generally we use PCA for making the groups, but it is not appropriate method for making the group. Correlation is more appropriate method for making the group. So obviously correlation will be better than the PCA analysis. Yeah.
Sir, another question is there, sir. Determine,
Yes, sir.
determine optimum number of cluster in k-means clustering based on graphs.
Yeah. Actually, this is a very good question, because when you go with the k-means clustering, you need to provide the number of clusters required for making the group in advance. You don't know actually what is the number of clusters. Okay, so there are several methods available for guessing what exactly should be the number of cluster. Okay, one method I am recommending you, that is called consensus clustering. Okay, and there is a package also, I think conclust is named the package, that is available in the R, that you can use for getting the optimum number of package and optimum number of cluster for getting the idea of what should be the number in advance, because k-means clustering is very robust techniques, but it is only good when you have the idea of the number of clusters. So that you can use. That is called consensus. Yeah. Through graph also you will be getting a graph, and there you will getting the that is called delta graph, and there you will be getting the exact number of clusters which is required.
Sir, another question is augmented RCBD package available and installed from our library?
Yes, it is available.
And another
When
one.
you analyze treatments more than 3000, the result 5 don't contain all adjusted data.
How we can overcome this?
Okay. This is a very difficult question, because when you have the large number of like 3000 treatment when you have, so really it is out of capacity of using this, because for calculating the adjusted mean, it is highly computational intensive, so that's why it is not coming. So this is a type of big data problem. So at present I am not able to answer this question, but sure I will go through this, and what is the solution I will look into. Yeah.
Any other question, please? Yes. Dear participant, if you have any question, you can ask. I think, sir, there are no question now.
Okay, no problem. You can share my ID, and then I will be happy to answer if it is possible to answer. Yeah.
Okay, sir. Now I will propose a vote of thanks, sir. I, on my behalf and on behalf of organizer, I thank you very much for delivering such a wonderful lecture on this application of our software for PGR management. Sir, you have demonstrated our software in a stepwise manner using suitable examples, which will definitely help our participant for use of this software and analyze their research data for their future endeavor. Thank you very much, sir.
Thank you, Dr. Subhas.
Thank you, Dr. Dujes.
Thank you, ma'am. Thank you
for
for providing me the opportunity to present this.
Yeah, so for means talking about all the basic things, and then cluster and augmented also, as so certainly means the participant might have enjoyed, whoever might have using R, for them it would have been more useful, and whoever is not having much experience, they will try to learn themselves by further video and all like that. So certainly it would be useful for all the participants. So thank you very much for your
Thank you, madam. Thank you.
time and delivering nice lecture.
Thank you, madam.
Yeah, thank you, Dujes.
Thank you very much, sir.
Thank you. May I leave now?
Yes, sir. Thank you. Okay, dear participant, we will meet tomorrow at 9:30. And today is over. Okay,
sir.
Okay, thank you very much.
Thank you, sir. Thank you.
डॉक्टर साहब मीटिंग क्लोज कर दूं?
Yes, डॉक्टर साहब.
मंडल जी.
यस मैम.
ये अभी वीडियो होस्ट नहीं हो रहा है क्या यूट्यूब पे और ट्विटर? नहीं, इधर पार्टिसिपेंट पूछ रहे थे, मुझे लग रहा है 2 दिन का, डे 8 डे 9 का
फोन आया था, मैंने उन पार्टिसिपेंट को बोला था
हाँ हाँ
पे जाके देखेंगे तो थोड़ा सा टाइम लगता है, लेकिन हो गया, पब्लिश है।
ओके ओके ओके
ठीक है।
ओके, मैंने चेक नहीं किया, और ट्विटर पे भी आ रहा है ना?
हाँ हाँ।
ठीक है हाँ ओके।